अनिल सर, अनिल कुंवर सर।
हेलो। हाँ बोलिए सर।
Actually, I think I saw somewhere. I was in Jamia Millia, did the
या
you know.
यस
So in 2014 to 2017, I think I saw your face.
यस यस
Am
यस
I correct?
यस 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 करेक्ट।
Correct, na?
हाँ करेक्ट करेक्ट।
Actually, I did postdoctoral DS Kothari postdoctoral fellowship under
या
Professor Sharif Ahmad.
ओके यस यस सर।
So that time you were there.
नो नो आई एम लेफ्ट फ्रॉम देयर।
Yeah, but that time I saw you.
या यस यस
Actually, many times na last 6 7 days na I saw your face. So
यस
I saw, I think I saw somewhere in Jamia. Actually, your name was Hindu, na, I think maybe I confused. So today just I. So
ओके
sir, where
यस।
are you nowadays?
नाउ आई एम इन द महाराष्ट्र।
Okay, okay, okay. Nice,
नांदेड़
sir.
नांदेड़ नांदेड़।
Okay, okay. So where you belong, sir?
हाँ
From where you belong?
हेलो आई कैन अंडरस्टैंड।
Sir, you belongs UP side or
नो महाराष्ट्र 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 सर।
oh,
हाँ
Maharashtra.
हाँ हाँ।
Nice, sir. Thank you. Nice to see you again.
ओके ओके सर यू शुड कॉल माय इन पर्सन नंबर सर।
Yeah, yeah, sure, sir. Sure, sure. I will
श्योर
message you on your WhatsApp, so we will talk you. Huh?
यस 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 सर।
Okay, sir. Thank you. Thank you, sir.
কোনো কথা বলছো না তুমি মিটিং এ? অবশ্যই। তারপরে আবার এমবিবিডি কে তো ওই ইনফরমেশন তুমি জানিয়ে দিয়েছো সেদিন যেটা আলোচনা হলো।
Again. So as you know that this is the eighth day of our refresher course, and in the morning session today we have with us a person from the Institution of Immunology, that is the ISER, Dr. Nirja Dashaputre Madam. Madam, first of all, I extend my warm welcome on behalf of the Malviya Mission Teacher Training Centers and Gadge Baba Amravati University to this refresher course and particularly to this session. I also extend my warm welcome to all the learned participants, those who have gathered here for this refresher course from across country, from the different HEIs of the HEI of our countries. Friends, whenever we are going to conduct any kind of teaching, learning, or the research, the assessment is very much important. And without the assessment, we cannot award any kind of degrees or any kind of diplomas or certificates or marks particularly. And in the recent terms, we cannot award the credits. So the assessment is very much important in entire our ecosystem. So today we will going to discuss this much important aspect, that is the assessment in the chemistry, with the help of Dr. Nirja ma'am. So first of all, may I request Dr. Mithilesh sir to please introduce our guest in brief, and then we will start with the session. Yes, Dr. Mithilesh ji, please.
Yeah, Pankaj ji, thank you. Am I audible?
Yeah, sir, clearly, please.
So, good morning, everyone. Respected course coordinator, Professor Manisha Podape, Madam, technical support person Ankit ji, distinguished colleagues and dear participants. I am Dr. Mithilesh Yadav, working as an assistant professor in Veer Bahadur Singh Purvanchal Vishwavidyalaya, Jaunpur, UP, and it is my distinct pleasure to welcome you all to live session first on the 8th day of our refresher course in chemistry, organized by the UGC Malviya Mission Teacher Training Center at St. Gadge Baba Amravati University. Today we are addressing a highly relevant and modern theme for educators, the evolution of teaching methodology in our discipline. To guide us through this, we have a phenomenal expert as our resource person, Dr. Nirja Dasputre. Dr. Dasputre currently served as the Principal Technical Officer in Education at the prestigious Indian Institute of Science, Education and Research, IISER, Pune. Looking at her remarkable academic journey, she completed her undergraduate studies in chemical technology at the Institute of Chemical Technology, ICT, Mumbai. She then earned her PhD in organic chemistry from the University of Maryland, USA. It was during her time in US that she discovered her true passion for teaching and formally completed the university teaching and learning program there. Dr. Dashputre brings with her over 12 years of rich teaching experience across both India and the USA, having previously served as a faculty member at Claremont University. She specializes deeply in designing inquiry-based pedagogy for chemistry education at both school and higher education level. At IISER Pune, she works extremely with prominent teacher education and science activity initiatives. Her expertise is widely recognized at the national level. She is an active member of several national committees, including NCRT and SCRT textbook writing and review committees. Furthermore, she is actively involved in national and international chemistry Olympiads and recently represented India as part of an official delegation to the UAE. An interesting facet of her personality is that outside of her core scientific work, she is a passionate painter and poetry artist. She wonderfully connects these personal interests by exploring creative ways to integrate arts into science education to enrich the learning experience. Today, she will be sharing her vast experience on the topic digital pedagogies for chemistry work. We are incredibly fortunate to have her with us today to share these valuable insights. Without taking any more of your time, I warmly invite our esteemed resource person, Dr. Nirja Dashputre, madam, to kindly take over the session. Please, ma'am.
Thank you, sir. Thank
Hello.
you. And participant, one of the important thing that has been not mentioned in the ma'am CV or the introduction, she was closely associated with this faculty development initiative that has been taken by the government of Maharashtra. And the IISER Pune has designed one specific program that is the MSD program. And I think the team IISER has crossed more than has trained more than 1 lakh faculties across the Maharashtra towards this says inquiry-based and experimental learning education. So, ma'am, I once again extend my warm welcome and request you to please start with the session, ma'am, please.
Thank you so much.
Thank you,
Am I
ma'am. Thank you.
audible, everyone?
Very much clear, ma'am. Very much clear.
Okay, okay.
Yes,
So,
ma'am.
I personally am very thankful to SGBAU for inviting me here. It's always a pleasure to work with SGBAU, and it brings me back to our memories in Amravati when we were there for in-person training, and we got to meet many faculty members within Amravati during that time. I think it was 2 to 3 years ago, and we look forward to coming over again sometimes. So a little bit about today's session, we are going to discuss about digital pedagogies. And I'm sure that all of you have been using a lot of, digital pedagogies in your classrooms. Especially post-COVID, there is a lot of shift in the way we look at teaching and learning. So I want the session to be more interactive, where you also tell me what is happening in the classroom, and I could share some of the things that we have been doing. So we all get to learn from each other, because in this new era of AI and digital tools, it is somewhere more important that the teacher community comes together. Teacher community discusses what works in the classroom, what doesn't work in the classroom, what our students are really liking, what we are really liking to do in the classroom, because all of these tools are new to us. They didn't exist when we were students, definitely. And even for, as you know, as with each passing day, I would say there are more and more digital tools in the market. So I'm going to focus on some of the ones that I have personally used. But if there are better tools that you know, please share them, because it only helps all of us if we know from or get to know from each other. So just give me 1 second until I share my screen. 1 second. Yes, so as I was saying, we'll talk about how we can integrate technology into our teaching. And before we go ahead, I know that we are going to talk about ICT, but I would like to ask all of you one question. And that one question is, what do you think is the purpose of chemistry education? I will now frame that question a little differently than, when I'm addressing everyone, I typically just say, what is the purpose of education? But according to you, why do we teach chemistry? Can we have some answers in the chat box, or you can just unmute yourself and, let us know what you think?
Chemistry is a basic root of all the science, I believe.
Okay.
So it's very essential, it's intermingled with all the disciplines. So I think it's a very important field. That's what I think.
Okay, so connecting disciplines. Okay. Why do we teach chemistry, or what? Thank you, Archana ma'am, by the way, for the answer. But other than that, are there any other reasons? Because then physics will say physics is the like the main stream that connects all science, and then bio will come forward, and pretty much science is interdisciplinary. So according to you, as a teacher, what is the one thing that chemistry really focuses on, or why should we teach chemistry?
It's present everywhere in our life.
Okay, so it's relevance in day-to-day life.
To understand how the world work at a fundamental.
So understand how the work in the
World
sense.
works at a fundamental level to
Okay,
study
how the
out the
world
fundamental
really
phenomena.
functions. Yes, thank you
Yes.
so much. Any other reason?
I think basic elements of life.
Okay.
So that's how life has started, with the basic, amino acids, and so that.
Wonderful. Now think about it, that do all of our students really become professional chemists at the end of graduation? Will all of them become faculty? Will all of them go into industry, or do anything closer to chemistry? According to you, what is the percentage of students that will go work specifically in a chemistry domain after BSc chemistry or MSc chemistry?
It is very little
20 to
amount,
23%.
20 to 30%.
30%.
Right. I'll also say it's hardly 20-30%.
Hardly some
Rest, yeah.
percentage, right? I mean, I wish that the percentage was very high, but unfortunately, in my case also, if I think about my class of 250 every year, out of that, hardly a few will get into chemistry research. So then when I'm teaching chemistry, should I just focus on the content, or should I focus on some other things other than the content? Of course, the content is going to be the way we communicate these skills, the way we communicate some of these attitudes. But much more importantly, should we work with them on getting some essential skills that are important for their future career or future, profession that they get into? Because I mean, the more and more we are, seeing as the trend in education, BSc chemistry or MSc chemistry is going to be known as the first degree. It's not the ultimate degree. Think about it. In my parents' generation, for example, MSc हो गया तो बहुत अच्छा काम किया, right? I mean, that was the thing. Like most of the really well-learned people were MSc or BSc graduates. But now these are our first step in the in the professional degree curriculum, I would say. So in this particular curriculum, if we want to now focus what is the purpose of education, one could be basically, one thing is understanding the concept and the processes, the various skills that they want to get, but also towards making them a good human being, also making them a good human being that contributes to the society, or a human being that can work with other teammates, a human being that can communicate, collaborate. Can we get them to think a little broadly about how the world functions, or somebody or a student who can really think critically, doesn't matter about chemistry or not, but in general has a very scientific aptitude or scientific attitude towards looking at any problem? Because tomorrow my chemistry student can get into civil engineering project, very much possible, and he or she may have to apply some of the things that they have learned here to really tackle problems in that field. Or they could get into banking sector, or they could get into investment sector. I really don't know how their career progression really will be, but one thing is sure, that the skills that they learn here will be much more important as they go ahead, rather than the exact concepts of chemistry. I'm nowhere saying that the concepts of chemistry are not important. Please, I mean, if I'm saying it out loud, I'm doing it for a purpose, is that along with the concepts, let us also pay attention to the skills. Let us also pay attention to the attitude or, values that we really bring to the table. So if I think about it, knowledge is, yes, facts, figures, concepts, ideas, information. Chemistry, yes, we will do that. But apart from that, intellectual skills to look at data, let's say, given any data, can my student figure out whether the data makes sense, what kind of trend is seen, or can my student figure out if a report is written, can they figure out the gist of the report without, doesn't matter what the topic of the report is, or can they interact socially, can they work with teams of diverse backgrounds, can they communicate their findings better with the other students? When it comes to attitude, do they have a curious attitude, like at the end of first day of college versus the last day of college? Have I worked on their curiosity? Are they still the same way curious, or they are like, "अभी बहुत हो गया पढ़ना, I don't want to learn anymore, like it's too much, too boring"? Have I worked on that? Have I worked on the motivation? Have I worked on resilience? That is, if they get something wrong, do they have the inner drive to say, hey, it's okay, I can get it done, I can work on it, and next day I will succeed? So in our classroom, can we work on all of these things? And chemistry, physics, maths, bio, it doesn't matter which subject you are teaching or learning, for that matter, these things become fundamental. So when we think about attitude, knowledge, and skills, I always say it ASK, like ask. So to remember it, always think about within the topic that you are teaching, where is the scope to instill some attitude? Where is the scope to instill some skills? And then we can go about, providing the right tools. So this is where ICT comes in, providing the right tools for getting that attitude instilled, providing the right skills to get that attitude instilled. So if we think about ICT and how ICT has really progressed in the last quite 100 decades, initially when the first printing press was made, it was thought that now knowledge is available in plenty. We really don't need anybody to do anything more, like now whatever is known is available in the form of books. You don't need a teacher. Then better printing press came, you had books in plenty, the information was available in plenty. Now you also have computers, which were then made even fancier, tablets that had internet connection. The entire world is pretty much available at your fingertips. And thus it almost became kind of a saying that, hey, now we don't need teachers anymore. We are done with the need of teachers. And the truth is, more and more as we go ahead in this world, as AI has approached us, as we have seen newer tools coming in, the need of the teacher is becoming even more and more evident. Because the tools can tell you the information, but the attitude and the skills are somewhere given mainly through interaction in the classroom, They are given through interaction with the classmates and with your teacher. So as teachers, let us identify our needs. So the ICT tools that we will talk about today, the simulations or the AI tools or any kind of other graphical tools that we will discuss, they are not to be looked as tools, but how can I use it in my classroom such that I can work around giving my portion or my part into the students' learning. So let us look at it from that point of view. And in this regards, I really like the way this particular saying is that before school computers could change the schools changed computers. So anybody knows what this whole thing has been about? Anybody can figure out what or would like to opine on this, that there is a very famous saying that before the computers could change the schools changed the computers. Can we think about how we use computers in our classrooms?
Ma'am, computer changes schools because the teaching learning methodology will be changing when you are using this.
Right. So that's what was expected when computers first arrived. We thought, hey, we have a new tool which is really amazing and it will change or revolutionize education, right? Before that, we were using chalk and board. We used to write on chalk on the board with the chalk, and the teacher used to teach and the students used to listen, and there was a flow of knowledge. Now then, majority wise, when people started using computers, unfortunately, they started using computers just like chalk and board. We do PowerPoint presentations, which are very much similar to chalk and board, right? It's just a way to communicate written information. Can we think of computers in any other way where the students will use the I would say the advantages of having a computer were overlooked because we started using computers just like chalk and board. So can we think of using this technology to its full potential such that the skills and the attitude can be addressed? Somebody wanted to say something. I think
Smart.
Mitali ma'am, yes.
Now in school, smart board is using. It's
Right.
also
Absolutely. So smart board is there, but can we go beyond it as its use as a board?
We
No, again,
using
when we start thinking about chalk and board, we are again one-way communication where the teacher is saying something, writing some information on the board, the students are learning it. Can there be another way in which this particular technology be used in our classroom?
Yes, ma'am.
Yes,
In our
Salim sir.
classroom, we used to support the students to visualize the concepts, particularly in
Wow.
chemistry. Some concepts they could not understand when we use the chalk and board method simply. That time, we asked the students to search for websites to see the animated videos so that they could easily understand the concept.
Nice. So now Salim sir is saying where he has gone one step ahead, where he has given I would say the ownership of learning to the students, saying that, hey, you cannot understand these concepts, go ahead and look at these videos or search for videos that explain these concepts or explain it in a visually better manner. Chalk and board cannot do. Now what does think about what the student has to do. The student has to go ahead, search, think about whether the particular video is good or bad, and then come back to the classroom saying this video was particularly good, this video didn't particularly do well, or things like that. Meaning somewhere the student skills about um, figuring out what is the right information, what is the wrong information. If given a topic, can I search on a particular topic and get to the right information? They are being developed. So my point here is that can we think about ICT towards skill building, which is the real skills that the students are going to need? Things like, given any information, can I verify it? Tomorrow, for example, I get a WhatsApp message that says such and such thing has happened. or such and such thing is available or seen in the world, my first instinct is, do I believe it, or do I really test and verify the information before I really start believing in it, right? Not only about chemistry, again, all of these are universal learning skills which they will apply to any other field that they will get into, or even chemistry. So when it comes to achieving these other learning outcomes, which are about skills and attitude also, not just about the concepts, we have to think about how we go about backward designing in our content, right? So the typical instructor-centered model that we have here, for example, this one, which is mainly, I know that I have to teach a particular syllabus. There is somebody, some board, some BOS that has said that this is the syllabus. I look at the syllabus, then I prepare lectures, notes, PPTs, and then I go in the classroom. I teach based on that particular notes or PPTs that I have made. Students listen, students will probably discuss. There will be some activities in the classroom also. And then I go and design the exam paper and then set assignments, etc. So for quite a few of the teachers that I have personally talked to, I'm not sure how many of you follow it, but many of us follow this instructor centered model, which is mainly ye padhana hai, I will prepare my lectures, this is how I will test if the students have understood or not. That is what I will be keeping, as my way of, or the sequence in which I do. On the other hand, if we have to go towards a student centered model, okay, first is to think, what do I want my students to know or to be able to do at the end of the year? For example, if I want my students to know Boyle's law, or if I want my students to be able to write down Boyle's law, yes, then I will test on whether they can write down Boyle's law. But if I want my students to really understand how Boyle's law is applied in everyday life, I will have to then design my assessment very differently. I will have to then think about giving them real life situations, seeing if they can apply Boyle's law properly, and then, figuring out if they were able to do it or not. Meaning now my shift is now not towards what I can teach in the classroom, but towards what I want my students to learn at the end of the year. So this particular sequence, which is a sequence of first identify where you wish to go, right? Then kind of understand, how do I know if I've reached there or not? And the third part is, how do I get there? So tomorrow, for example, if you tell me that I have to come to Amravati, first thing I will ask is, okay, first I need to decide that I have to go to Amravati. But more importantly, how will I know that whether I've reached Amravati or not? Right? And then you will say, okay, if you have reached this and this particular station, then you are in Amravati. And then I'm like, okay, great. Now I know that I have to reach there. I will know if I have reached this station, I have reached Amravati. But more importantly, then the third part becomes, then I will plan my journey, right? Then I will say, okay, I will probably first go to Nagpur, then come to Amravati, or I will take a direct highway from Pune to Amravati. Depends on my mode of transport. I will then plan the lesson accordingly. Very often we plan the lesson first. That is, I decide that I want to go to Amravati. I plan the lesson, I start traveling, and then I decide, hey, have I reached Amravati or not? That doesn't work, right? So we have to plan our learning outcomes first, then assessments, and then choose the appropriate learning activities. So in the ICT as well, remember, ICT is a tool. ICT is a way to make our learning activities better. And so the first part is again learning outcomes and assessments. Can I make these two very concrete and then start, towards using ICT in my classroom? And we can, of course, work with ICT for assessment and learning outcomes also. We'll just discuss that after this particular thing. But the idea here is, can I can I basically start looking at my teaching as a way to ensure that the students are fulfilling their learning outcomes, or they are able to reach the destination that they have to, right? And that's why there has to be a perfect alignment between the learning outcome, the learning activities, and assessments. I'll just give you a very simple example. If I ask my students to write down Schrodinger's equation, okay, so there is a paper that we teach here, which is in quantum chemistry, and I ask my students write down the Schrodinger's equation. According to you, do you think this particular assessment tests whether my students really have understood Schrodinger's equation or not? What do you think? Has everyone understood the question here? That if I write down a question in my exam, which is about, write down the Schrodinger's equation, do you think what am I really testing with this question?
Just their remembering capacity, ma'am.
Right. So somewhere probably there is a student who has not understood anything at all, who has memorized it completely, and who gives me this entire equation, which is, a little complicated to understand for the students, let's say. But I am only testing whether they are able to write it down or not, right? As a teacher, and I give them full points. Right? So there is a big discrepancy in the learning outcomes and assessments, because my outcome was somewhere where I wanted the student to completely understand the Schrodinger's equation, or be able to apply it, or be able to evaluate whether the proof is correct or incorrect or something like that. But now, since I'm asking them to write it down, my only way of assessment becomes whether they have remembered it or not. So if I don't have the alignment between learning outcomes and assessments, the learning somewhere fails, right? Tomorrow, if I want to, let's say, come up with the learning outcome that each student in my class is able to jump 5 feet, they do a long jump of 5 feet, my assessment cannot be write an essay on how to jump 5 feet. It cannot be. I'll have to ask them to perform that jump. If they're able to jump, yes, they are able to, they have acquired the skills. If they haven't, then I need to think about a better way to really assess, right? So this alignment between outcomes and assessment is very important. The alignment between assessments and learning activities is also equally important. For example, if I want all my students to jump 5 feet long, right? Assessment is you have to come there in the classroom on that day and show me that you can jump 5 feet. But in the learning activities also, I have to ensure that the student gets a chance to jump 5 feet. Sometimes they will not, they'll not be able to jump 5 feet. They'll jump only 4 feet. But I have to give them chance in the classroom to really try their learning. So unless all these three things are really aligned to each other, we cannot really achieve the outcomes that we want to achieve. Right? And ICT can help us in refining our learning outcomes. ICT can help us in refining our assessments. And ICT can also help us in refining our learning activities. All of these three things can be improved with the help of ICT. Sometimes you can also integrate ICT into the learning outcome. For example, let's say that performing titration is your learning outcome for a particular lab course, but then analyzing the data with the help of a particular program, let's say Excel or any other program that you wish to use, becomes a learning outcome that has been, enhanced with the help of ICT. Right? So I could refine all of these three things with the help of ICT. But before we go ahead and discuss the role of ICT, there is a lot of debate in education, especially It started around 1980s. That does ICT really improve learning? And let me tell you a story around this. I'm not sure how many of you have heard this story, but it's always good to hear some stories, right? So, what they did around in 1980s when the first time videos were introduced, they kind of divided the students into two groups. The first group was given a long essay to read. They had been given different paragraphs which talked about how the blood flows in the heart, right? And what the students were asked to do is they were asked to kind of show on a diagram how the heart flows, sorry, how the blood in the heart flows, right? And they were asked to discuss in the groups. They were asked to debate, based on the written information. They had to make sense of that information and then make a diagram of how the blood flow happens. On the other hand, the second group was just shown a video. It had a wonderful audio to it, and I can play it.
Chambers, the top receiving chambers, the atrium, and the lower chambers, which are thick-walled pumping chambers, called the ventricles. Red blood cell will come from either the superior vena cava or the inferior vena cava and enter into the right atrium. The blood then flows across the tricuspid valve to the right ventricle. Right ventricle then squeezes and ejects that blood cell into a vessel called the pulmonary artery. Pulmonary artery splits into two vessels, each going to the lungs. As that red blood cell makes its way through the lung, it returns.
We can see the whole video, but I think you get the gist that the second group saw a wonderful video, and then they were asked to kind of just remember based on what they saw. And then both the groups appeared for a test that asked them about how the blood flows in the heart. So, according to you, which group do you think did better? Was it the first group or was it the second group?
Second group is better.
So, sir is saying second group is better.
I think first.
Tanya ma'am is also saying second group. Somebody said the first group.
First
May I
group
know your
is
name?
better. They will understand when they are writing. First group is
Okay.
better.
No, ma'am.
Okay,
Second.
so we have I think two opinions. One is some of us are saying it is the first group, some of us are saying it is the second group, right? Can we have somebody who feels the first group did better explain why they think it was the first group?
Sir, I think, ma'am, I think the first group is better because they are more focused in how the blood is flowing and they draw it.
Okay. So
they more focus on the total process, not as the video is when they may be distracted on the different color and the voice, all these things.
okay, so there is a chance that the second group got distracted during the video. So the first group definitely did better. And some of us are saying the second group did better. So the answer is not both. One group definitely did better than the other. So
Fast
right
group
now,
will do better because of slow process. Slow process
because
accumulates
of slow
large.
process. So Anup
Yeah.
sir is saying that because they had time to really digest what is
Yeah.
happening,
Yeah,
the first
obviously
group will do
slow process accumulates better volume.
okay. And I think we have a lot of votes for the second group. So somebody from the second group, what do you wish to say about it? Somebody who says that second group does better. I'm going to randomly now ask who is saying second group. Tanya ma'am, what do you think? Why do you think that the second group did better?
That will be better. They will remember that now.
Okay, so they are probably able to see the visualization better, and that's why they will remember it. That's a fair point, and
They are
that is a
getting the
possibility.
concept clearly rather than a diagram.
Yes. So truth is that this was the start of videos, right? First around 1980s when the videos were made first time, and they thought, great, now we have videos in the classroom. We don't need teachers anymore. There is a lot of scope to teach using videos. The truth is the first group did better than the second one. And that could be surprising to some of us, but if you think about it very clearly, you have to think about what the students were doing in each case. In the first case, they were talking to each other. They were trying to make a sense about the writing. They were trying to, kind of evaluate their own thought processes. And they were trying to make a sense and, draw that diagram. They were heavily involved in that process. They were working together towards figuring something out, right? They were too keenly involved. Their minds, their brains were completely involved in that process. On the other hand, the second group, although they saw a very good fancy video, they could be thinking something completely different while watching the video. They never had a chance to discuss it with their peers. They never had a chance to discuss it and figure out something on their own. So every time this particular type of study that has happened, which is, what really works in science education, it's always the group that is more involved in learning, right? And that is always the case, that you have to have the students' minds on, not just hands on, not just, being able to sit in front of the screen and watching a nice video. It is always, what is the student's brain doing when they are learning? Is it completely focused on learning? If yes, great. They will learn no matter what method you use. So, although this is an ICT talk, remember and probably say it out loud that you don't need to use ICT for each and everything. You don't need to combine or make your classroom smarter with a smart board every single time. I've seen beautiful teaching happening even with regular chalk and board, where the students were heavily involved, right? So, in fact, after this study, many people started believing that media is basically a vehicle that delivers instruction, but it does not influence the student achievement, right? It's no more different than the truck that delivers our groceries causes changes in our nutrition. For example, the banana that comes to you, let's say via a truck or via a car, the food delivery person, doesn't really change how much nutrition I get from the banana. That's the analogy that the people in education sector started using. However, this is not the whole truth, right? So then they said, because there were, of course, people who are propagating these new technologies, and they said, hey, we are not convinced with this. Let us try to do one more thing, one more experiment. So this is around 1990s now, after 10 years from the first study. What they did was, they again made students into two groups, right? The students in group 1 were allowed to watch some videos. The students in group 2 were not allowed to watch the videos. On the other hand, both the set of students worked in groups to discuss and solve a few problems. And these problems were simple physics problems. And the videos that the first group watched were also about, how the water currents change and how the velocity of the boat changes and things like that. And turns out, if you keep the human element the same, in the sense both groups were heavily engaged in discussions and debate and figuring out the answers together, the group that had access to media did much better than the one that hadn't. So now the learners are engaged. If the learners are engaged, then the group that gets access to ICT is going to do much better. And that is where we have to really think that how we really learn and where technology can help us with the attitude, knowledge, and skills, right? And I mean, if we think about it, what we learn is, let's say today I hear a lecture, or today you are hearing a lecture that you have under this MMTTP. If you just passively listen to it, you will remember 5% of the lecture at the end of 2 weeks, right? And then if you think about it, if you have read about something, then you tend to remember 10% of it at the end of 2 weeks. If you see some kind of audio visual or some kind of video that you can see on a screen, you tend to remember it around 20%. a demonstration, if I had brought in some kind of live demo here where there is a lot of reactions happening and things, that you would have remembered 30% after some time. But if we were going to discuss something, if we all discuss something and we come up with some kind of resolution, there is a lot of debate happening, what you are saying, what I am saying, that kind of a thing you will remember up to 50%. If you actually practice it by doing, you will remember 75% of it. And on the other hand, if you end up teaching others, and most of you will agree with me here because all of you have been really good teachers, is when we teach others, we remember or retain something with us or learn something in a much, much more efficient way. That is 90%, right? So if we know that learning typically happens in this manner, where a larger retention is seen, where there is group discussion, hands-on, or teaching others, or there is some kind of communication, can we make our classroom kind of reflect something similar? Can we make our classrooms to have a lot of group discussions? Can we make our classrooms to have a lot of practice? That is either hands-on practice or, something, an activity that they do. And more importantly, can we get our students to have a chance to teach others such that they will retain the maximum out of it? Again, the lecture, reading, audiovisual, demonstration, if they are integrated into these activities, nothing like it, it only enhances. So you can always combine the passive learning methods with active learning methods to enhance the effectiveness of the active learning methods, right? So that is where we want to use technology. Let us use technology to integrate it into the active learning methods, and let us see how, right? And that's why when we are trying to integrate the technology, one important part is learning how people learn, or knowing how people really learn. And then it is not just about PCK, which is, pedagogical content knowledge. Can we enhance our own knowledge to be technological, pedagogical content knowledge? That is, I know the content of my topic. I know how to teach it better. I know which methods really work in learning. But I also know the technology that will enhance it further, which will enhance my own, effectiveness of teaching. That's the idea pretty much, right? So if we think about today's technology, now there are just too many different things in the market out there. There are also various apps. So there is, of course, e-learning, there is big data, there is, augmented reality, there is digital online assessments, gamification, there are various chemistry games that you can do. There is AI-enabled education, VR, AR. I could use it for learning management systems. There are like many, many things. And instead of going for all of them, we are going to selectively talk about a few of them, right? But before we go ahead, I do want to ask this question that many often we see or we read a book, right? And then when a movie comes on the same book, very often you will hear people say, hey, it's not the same, like I like the Harry Potter books so much better, but the movies did not do justice to these. Or it could be about any other book, that you might have read before and then saw a movie on the same. And the reason that this discrepancy happens, the reason that this shift that the viewers typically feel, is not because the movie makers did not want to replicate the book just like that. It is very often because the movie makers did not really think about the advantages of, an audiovisual medium that are over the written medium, and then, then try to implement it in the classroom, or then try to implement it in the movie that they were making. So when we as teachers, we want to try to do this shift where we are trying to shift from our regular traditional learning methods to a classroom that is, enabled with AI, to a classroom that is enabled with VR or AR or any of these new tools. Let us also see what are the strengths and the weaknesses of each of these mediums, because that's what will make sure that we are using it to the right extent. So for example, if I'm teaching classroom very regularly in the classroom, I could teach online using instructor videos or live feed. Or I could be giving students some textbooks, but later on I could give them blogs, notes, or written instructions. Trust me, this shift is not what we are calling as the shift with the help of ICT. Because in the classroom, if I'm standing in front of the board and giving instructions about how to draw a particular reaction mechanism, trust me, even if I make the video of me standing in front of the board and drawing the same reaction mechanism, I may have improved the learning by, let's say, 10-20%, because the student can now repeat the video and look at it again and again. But I haven't really used the strength of the media, which is the audiovisual media, to really make it work. So when we are thinking about these shifts, let us think about what is the best way to use that online or ICT tool, right? So the first thing is, again, we start with ILOs, then we plan the assessment, then we plan what are the best teaching practices, schedule and sequence the learning, and then the most important part comes in, that is what technology works best for my class. Remember, I do not start with technology. I do not say that I want to use this tool and that's why I'm going to teach it in this manner. No. I first think, what is my learning outcome? What are the assessments? What are the activities? And then I think, hey, can any of these technologies work for the activities in my classroom? Right? And so now when we focus on the blended learning part, where we are talking about what is blended learning, it is much more student centric. We are kind of combining the classroom training with e-learning together. We can think of many, many ways in which this blending can happen. For example, in the earlier times, what we used to do was we used to ask students to come to the classroom, which is, here. So for example, the students came to the classroom, they heard a lecture. Then you gave them some homework that they could do as they went home. So they went home, they tried some homework problems, they maybe read something. And then we kind of assumed that the rest of the learning continues after that part, right? So let's say I've taught a class on pH. I give them a few problems to solve on pH. And then I kind of assume that the learning on the topic pH keeps on continuing as the semester progresses. On the other hand, I can now think about kind of mixing and matching, or rather, this is called as chunking, my whole experience of teaching and learning. For example, I could first ask them to see a video. Sorry. I could first ask them to see a video and come to class, which could be about how, pH or acids and bases work. Then I could have a discussion about the video that they saw when they came to class. So this is something different than me starting with a lecture. I first ask them, hey, you saw the video, what really happened in the video? Did you understand it completely? Then after that, after the class, I give them some kind of simulation to try, something that they could do at home, or in the computer lab in the college, whichever one is feasible. Then they come back to the class again, we practice some more problem solving. Then I give them another activity that they could do at home. Maybe they could make a pH indicator at home and try the testing the pH of various things in their surroundings. Then we come back to the classroom, discuss their results again. There is some online problem solving that could happen, and then there is out of class homework or project, so they could continue with, let's say, some other way in which they start or continue learning with these with the concept of pH, let's say through an online test, through an online self-learning assignment. But basically, instead of it having like classwork, homework, and then learning continues, instead of having it in 3 chunks, now I'm kind of breaking the same experience such that I have a modification of something that they do at home, come to class, there is discussion. Then again, I give them something to do at home, which could be ICT based, which could be non-ICT based also. But again, they come to class, we discuss on what happened, and so on and so forth. So you're giving them a chance to really address this kind of sequence in which they should be learning. So instead of having a platter that looks like this on this side, which is, you have everything in front of you, instead of that, can we have it like small portion wise, that I initially just have the starters, then I have a salad, then I'll have the main course, then I'll have the desserts. So kind of going from one end to another in a very particular sequence in the classroom. And this is what is going to be more and more important as we start integrating ICT. So now when we
a flipped class,
yes, so this is something similar to a flipped class. So for example, if I had given them a video to see or a paper to read, and then they came to a class and then we did some activity, it becomes a flipped class, right? What you were supposed to do in the homework, you kind of gave them as a classwork. What you were doing in the classwork, which was the information transfer, where you were standing in front of the board and giving them a lecture. Instead of that, the person in the video is giving them a lecture, right? So this is very much similar to a flipped classroom, and that is where the best use of ICT can be really made. Like, we can really make use of flipped classroom if we give the students a chance to look at videos, read resources or simulations at home, then come to class and discuss with them. So if we think about the digital pedagogy, specifically for chemistry, there are various things that we can again think about. One is about molecular visualization, Avogadro or JMOL or ChemDoodle. When it comes to 3D structures or orbitals, students really get a huge help when they start visualizing it, right? Or we could do virtual chemistry labs where the students could try some of the experiments that we don't have access to. So very often we may not have access to each and everything in our labs, right? Or some experiments are just too difficult to perform. So we could do them virtually. There is AR, VR chemistry. Labster is very good. We could discuss that also. Simulation based inquiry, digital assessments. There is something wonderful called as Arduino Science Journal. So we'll discuss about that. But the idea here is that there are many different tools already available. So one approach could be, I will try to explore some tools. The one that works best for my class becomes my tool for that particular lesson. It's always a good practice not to try 10 different tools or give students 10 different tools, because then they get thoroughly confused. So then what we do is we say that, hey, I'm going to start working with PhET as my simulation, and let us start using PhET for multiple topics. Then the students also get proficient over time. So I'm going to talk about a few simulations now. So I'm going to talk about PhET and CT STEM today. How many of us have been using PhET? It's phet.colorado.edu. Have we used it, or is this a new tool for everyone? You can just tell me in the chat box. Okay, so it's a new tool. Great. So then what I will do is I'll also give a brief introduction to PhET so that all of us are sure about it. Let me just share my screen, which has the PhET. One second, huh? I'll just quickly share the screen that has the PhET website open. So phet.colorado.edu is a website that is mainly made for teaching sciences, specifically in a simulation based format. So I'm going to now show you PhET. So can everyone see my screen?
Yes, ma'am.
Yes, ma'am.
Yeah. So if
Yes,
you
ma'am.
go here, so what does it say? Interactive simulations for science and mathematics, meaning the students can interact with the simulation. It's not a one-way video, but the students can change parameters and the results change accordingly based on what the parameter the student has chosen. Now there are simulations for physics, maths, chemistry, earth and climate science, biology also. And so you could explore many of these, because very often some chemistry concepts are also integrated well with physics. Some of them are well integrated with bio and so on and so forth. So don't only explore for chemistry, do try it out with other things. Then there are also translated simulations. So if our students are not well versed in English, we can give them a chance to explore in Marathi. So right now, for example, I don't know how many of you feel English is the most preferred language and would prefer me to shift to Marathi once in a while, or prefer me to shift to Hindi once in a while. So it always helps to kind of know that beforehand. So do let me know, by the way, anytime you want me to shift to these other languages, we can always discuss that. Right now, anybody wants me to shift the language of instruction?
No, ma'am.
No?
We can use my mother language, but we are from different places. So
better to just use English.
English. Yeah.
Okay.
English is
So
good.
what I will say is we will continue speaking in English. In the somewhere in the middle, I may use some Hindi or some Marathi. If you wish to speak in Hindi, Marathi, English, these are the three languages that I understand. So please feel free to use any of them, right? Okay. So if I basically go in translated simulations, I can also see various other languages that the simulations are available in. So starting from African, but you will also see all the Indian languages also are also there. So there are Marathi simulations, there are Hindi simulations, there are, Kannada, if any of us are from Malayalam, Marathi, you can see there are various simulations already available, which is a great thing for our students, especially if they feel shy when English comes in the middle of their learning, right? Okay, so now I'm in the chemistry simulations. As you can see, there are various topics. So membrane transport, quantum coin toss, density, Fourier transform, diffusion, gas properties, molecule polarity, so on and so forth. There is like just so many different ways that I can explore. So for example, I'm going to take the simulation here, pH, okay, because we were discussing about pH. But this is a simple simulation. So for example, if I fill water here, okay, and I check the pH, I can kind of see that the pH is at 7. But then if I add some battery acid, some little bit of it, and I check the pH, right, it is close to 1. Now I'm modifying these parameters based on what I think is right. So you can ask me, hey Neeraja, how much water would you need in the battery acid, in 0.1 liter battery acid, to make the pH come to 7? Right now the pH is at 1, and I could have to calculate. I could also check it, like I could add water, but then you will see that no matter how much water I'm adding, let's say if I have a 1.2 liter, I can never get the pH close to 7. So that tells me that, when I'm changing the pH to go from really low pH to even a neutral pH, it's a large shift. So it's not like I have to add 7 times the volume. I have to add 10 raised to 7 times the volume of water to really dilute it, right? So I could make a lot of these changes here. I could then go for orange juice or coffee or any of these regular things. The point is that what I change is in my hand. I am deciding as a learner what needs to be done. I could go back, and now let us look at some other simulation. By the way, one good thing about FET is if you make a teacher's account, which is a free account, you can also access the teaching resources. So you can look at teacher tips. So it talks about what way the simulation works. It also talks about, various activities that you could do. So for example, here you will see that they have written figured out various activities. So there is already a worksheet submitted by some teacher. There is exploring pH and its variation. Somebody else has also done through water dilution. They have given a pre-made worksheet for you, so you could pick up some of the activities. So teachers have come together to really create a resource of what all activities could be done, and you can kind of go through all of them and see which one works better for your classroom. So now this was a very simple topic, but I could go and look at some really advanced topic also. For example, I'm going to take molecules and light. Now, this becomes a very difficult thing for our students to visualize, right? How different molecules interact with different types of radiation. So, for example, here, I'm going to start the simulation. This is carbon monoxide. And now if I shine infrared light on it, what do you think will happen? So what is happening as I'm shining the infrared light on carbon monoxide? Can someone tell me?
Some portion is going straight forward, some is getting deflected.
Vibrations,
Okay.
ma'am.
Right. So not all the absolutely. So not all the infrared radiation is getting absorbed by molecules. Some part of it is also getting reflected. But what is happening is as the molecule absorbs that energy, the vibrations or the stretching of the carbon oxygen bond happens. Right. So I could ask my students to observe. Now, if I change it to nitrogen, what happens? So carbon monoxide versus N2, both are diatomic molecules, but one behaves very differently than the other, right? So then I could think and ask the students question about, hey, why do you think this is happening? Why is carbon monoxide behaving differently as that of nitrogen? Or I could, for example, look at infrared and, or let's do this one, visible and carbon dioxide. So what is happening? Nothing, right? I could think about methane. Nothing happens to at the visible light. But now let's change methane to infrared. So now instead of the stretching, you can have these wobbling kind of a movement, right? So you can have bending of the carbon oxygen, carbon hydrogen bond. It can start bending in a particular manner. I could also give a very everyday application for students to explore. So like how microwave waves really affect water molecules. So now there is no stretching happening, but rotation happens. And then I could discuss about how microwave really works in everyday life. Or I could start about talking about ultraviolet and how ozone gets affected. Right? So now ultraviolet will affect the ozone. But for example, microwave will not affect ozone. Not in the same manner. Right? So microwave is able to rotate ozone, but ultraviolet is able to break ozone. Right? I can have ozone layer depletion happening when UV light gets exposed to ozone, right? But basically, I can ask students to look at these themselves. So if you have a computer lab or if you have a classroom where even one computer is available where you can show them these things, the learning can be enhanced tremendously. This is a website that is free for everyone. All you need to do is make a free account. Your students can also try it at home. Also, if there is no internet at your college, which I understand there could be, that could be one of the limitations, you can download a simulation on a pen drive and take it to your classroom. So wherever, let's say at home, you have internet available or some other place where internet is available, just download it in the pen drive, take it to the classroom, which is where I personally feel like there is a lot of scope that we can do with these. And not necessary that every particular student has their own computer, not necessary at all. Because what I have seen really work wonders is that I very often start the simulation in the classroom and I ask the students, hey, how should we modify it now? And then they say, ma'am, please आप वो ultraviolet on कीजिए. Let's see what happens to ozone. Let's see what happens to water. And then we do it together. So I don't really need to have a computer for each and every student, but we can also design our explorations together. And there are many of these, chemistry simulations. You can definitely try many of these. of course, try other things also, because the earth and climate, for example, has wonderful things that can be tried in the classroom also. For example, this is a diffusion simulation, and just to show you how beautifully we can change various things. So for example, I could add 20 particles on this side and 10 particles on this side, or maybe let's make it 60. But I'm going to change the mass of these red particles high and the mass of these blue particles really low, right? And I'm going to also change the radius here to really go low. So the blue particles are really smaller in size, whereas the red particles are bigger in size. And I will make the initial temperature of these go really high, these go really low. And when I remove the divider, you will see how the movement really is dependent on size. It is dependent on, the mass of the particles. I could look at the flow rate, how the particles are moving. I could look where the center of mass is for each one of these particles. I could then also add a scale, add a stopwatch, basically collect data, right? I can look at the average temperature now of the system. I can look at blue particles. See, now it's almost coming to an equilibrium, 5 and 5 here, 4 and 6 there, 3 and 7 there, 25, 35. But this really breaks that one misconception that it's not like both the compartments will always have 5 and 5. It's a thermodynamic equilibrium, meaning I'm going to see the average temperature come to almost the same, and I'm going to see the particles keep on moving, in these two chambers. So this is one simulation that you can try. I will now show another simulation that can be tried in the classroom. So let me share. So this particular website is called as CT STEM. Okay. So this is computational tool for STEM education. And here what we are going to do is this is something very similar to PhET, but in PhET, it is required that the teacher and student are talking to each other. On the other hand, the CT STEM website works such that you can assign a particular simulation to a student, and the student will go through the simulation themselves and will be asked questions in the middle such that they can keep a track of what they are learning and how they are learning, right? So if you look at the curricula, again, you have multiple different simulations available. We could look at the chemistry simulations available, right? So there are various chemistry simulations available. Let us choose the ideal gas laws, right? And I'm just going to look at some of the okay, let us look at volume and pressure, one of the things, right? So I'm going to say view as a student. Let us go one by one, right? So as the student starts this volume and pressure, they ask students to explore or ask some of the questions like, if you do this, what do you think happens to the pressure? Why do you think the marshmallow increases in size as you, release the pressure, and so on and so forth. But if you go ahead, it does ask students to go step by step, right? That now there are questions that the student has to answer. So what is the difference when the plunger is pushed all the way versus it's pulled all the way? Draw a sketch for each condition. So it asks students to really think about the experiment that they are going to do. Please explain your sketch verbally. Did gas pressure factor into your thinking? Did you think about it? Or why do you think a marshmallow is used in this experiment? So here what is happening is when I assign this particular lesson to my student, the student is free to do these things at their own time, let's say at home or in the library. We can give them or assign this. So this is very easy for me as a teacher, and I'll also show you how I assign it to my students. But what they write, I can see, and I can also grade them based on that. Now, if I go here, if you see, it's very similar to PhET. So that's why I'm not going to go down. But think about the now they are asking students to come up with the mathematical model. And let's say, for example, here they can change the number of particles and initial wall positions. And then when I say run, it can tell me how the pressure versus time graph is really changing, right? I could move the wall to the right. That means I am increasing the volume of the container. The earlier part, the volume of the container was small, but if I enlarge it, now remember the pressure has gone down, right? Can you see that? As the volume increased, right? As the volume increased, the pressure has gone down. Or I could decrease the volume of my container, right? So initial wall positions, I will move the wall to the left as much as possible. Now I'm decreasing the volume. So you can see the volume graph going down, but the pressure graph is now increasing along with that. So let the students make these observations themselves. And then they are asked a few questions. Of course, there are questions at the bottom of this. So if you observe the pressure of 250, what would your volume be? Approximately, they are now asking for a pressure of 250, what would the volume be? Or they are asking, was your mathematical model correct? Which is, between the volume versus time versus pressure versus time. So here the student is able to answer things on their own. You could always try this with the student also. So I could start a particular simulation in the classroom and I could try it in the classroom as well. As a teacher, it is very easy for me to assign. So this is my teacher dashboard. So I say that in my class, so I have to first add the list of emails of my students here. And I'll say add students and, it will let me upload. And then I just say assign. And then it will ask me which chapter do you want to assign. And I say, I want to assign the particular gas laws chapter and I want to assign the pressure and volume relationship. And then it just sends students the notification. The students can try it on their own and you get to track how the students are doing. So the idea here is that we are now working with the students on multiple skills. One is, can they manipulate things on their own in a simulation? Can they look at the data themselves? Can they make sense of the data? Can they write it down, right? So there are many other skills that get incorporated into my classroom rather than me just telling them that as the volume decreases, pressure increases. I could have done that in the classroom, right? Instead of that, I'm giving them a chance to explore it on their own, and that is how I'm going to progress with my class. Let me go back to the kind of simulations that we were doing. There are other things like Lab Exchange and Amritavi Labs also. So do explore these patterns or these particular websites. Lab Exchange is, for example, very good to visualize 3D molecules. It's very good to visualize large molecules, biomolecules and other things. On the other hand, Amrita Vishwa Vidyapitham is something that is very Indianized context. Many of our syllabus labs are already video recorded. They are also something that can be, done in the class with the students. So this was about simulations, and I'll skip this part, but do give it a read. I'll share the slides. I think we already talked about FET and CT STEM. You could ask students to try some experiments at home. And as they try the experiments at home, there are various things that they could do. Of course, there are, as somebody said at the start, that science is in our everyday life. So if you think about ISER Pune's website, we have documented many, around 500 activities that can be done with simple resources at home. So for example, this is a chromatography experiment that the students have done. And it's a very simple paper chromatography, but think about something different. Ask students to change the solvent, instead of water, why don't you run the same paper chromatography with sanitizer and water mixture? Does the RF value change? Ask them to do these things and come to the classroom and discuss with you. The Arduino Science Journal is a wonderful app that you can download on your phone. The beauty of it is it can record data in real time. For example, there are various sensors in the Arduino Science Journal. And some of these sensors can record pressure, some can record sound or frequency. Some of them can record so there is like a magnetic sensor and so on and so forth. But many things students could try at home with these Arduino Science Journals. So do have a look at it. I'm going to go to the next one. So when we are thinking about designing a class, let's start with the learning objective. Students will calculate mass of the product formed by converting moles to grams. Let's say it's a very simple learning objective, probably something that my students should know when they come to the first year. But very often I see that they are not able to apply it, right? So then I ask them to go to a FET simulation that, go to reactants, products, and leftovers. And can you really now tell me how much product is formed if I react these many grams of hydrogen and these many grams of oxygen, how much of water is really formed, and what is left over. So then they figure out the concept of limiting reagent. I can also use assessments that are technology based or ICT based. So I could look at LMS, learning management system, where there are auto graded problems. But again, think about what kind of assessment is the most important in this case, whether it really matches to the or aligns with the activity and the objective. So I could also do a pen and paper based assessment. So don't think about that you want to integrate technology in each and every bit. Doesn't happen, won't work, right? Try to integrate technology only in the places that fits right for your classroom. You are the controller of your classroom. You're the designer of your classroom, right? So you get to think, do I need to use FET for all my lessons? No, probably not. But FET works wonderfully well for these concepts that I'm going to teach. So I'll use it only for that. Or FET will work wonderfully for an assessment that I wish to do. For example, I assign students a FET simulation. I give them a worksheet. I ask them to complete the worksheet and come to the classroom, and I'll grade their worksheet. Think about what works or fits best for your class, and that is what will work, right? And there are various things that, when you think about the technological and pedagogical content knowledge, you could think about going in multiple ways. There are FET, there is Chem Collective, Molecule Viewer. So Avogadro works very nicely to visualize a molecule. Arduino Science Journal. Think about what are the pedagogical knowledge that you will need. For example, when I'm doing a FET simulation, I have to lead the students to think. I don't want to reveal the information or the answer myself. So I'll have to give them right prompts. For example, if they're trying to understand that stoichiometry, I could ask them, hey, what happens if you increase hydrogen to let's say 50 grams, but if you keep water to only 10? Does it work? How many grams of, sorry, if you increase the hydrogen to 50 grams, but if you keep the oxygen to only 10, how many grams of water is formed? So I have to come up with those prompts. So that is where your expertise as teachers, your understanding of where the students' misconceptions are, is going to play a role. So technology is not going to solve the entire problem. Technology will definitely make it easier for you to solve the problem together with the students. And here are some useful apps. One is Jamboard, Padlet, Concept Map. For engagement, you could try Bamboozle, Kahoot, Mentimeter. We could try Mentimeter. So let's try some Mentimeter in my next session. We'll try some of these things in the next session. But there are for various types of activities, there are different apps. And the world is full of these apps. So let's not spend our time into figuring out which 10 apps to use. Just figure out one that works best for your classroom and stick with it. It helps the students if you keep a consistency in the use of apps, because the aim is not to teach them how to use the app, but the aim is to use the app for your learning, right? So I'm going to show you how to use this particular app here, tarsiamaker.co.uk. How many of us have used Tarsia before? Is anyone saying? Okay. So no, then that's great, because then we can look at it again in detail. So this is a very simple thing. Now, this is not online. This is not a digital tool, but this particular website allows me to build puzzles that the students can solve. So this is particularly tarsiamaker.co.uk, right? So we'll try with a small triangle first because it's easier. So write down your question here. So what question do you want to say? I would say the atomic number of carbon, let's say, right? And the answer of that particular question I have to write down here. Can everyone see this? Right? So atomic number is correct?
Yes, ma'am.
Thank you, Syed sir.
6, it is
Atomic number is
6.
6, not 12, right? So the atomic number of carbon is 6. So I have to write down the question on one side and the answer on the other side. I was just checking how many of you are, kind of making sure that I am on the right track. Okay, so atomic number of carbon is 6. Let's say, let's come up with bonding. I mean, some other questions. I'm just giving you, so let's say this is covalent. I'm making very simple questions. You can, of course, make questions that are suitable for your class and, suitable for the concept that you are teaching. So carbon has hybridizations of sp3, sp2, sp, and so on and so forth. Basically, I can go on adding these questions. But as I'm adding these questions, I want you to pay attention to what is happening here, right? So now it has started arranging this particular triangle such that all of these get arranged such that there is a question, atomic number of carbon here, and its answer that comes right next to it, right? Or here, carbon has hybridizations of sp3, sp2, sp. So it's now aligned with that, right? Or covalent bonding, hydrogen bonding, right? Bonding in hydrogen, so on and so forth. I could go on writing these and I can have basically a particular puzzle with me. So this is like a jigsaw puzzle where there is an answer and there is a question, right? And so I have to piece together these things. So I can now do this, right? Or it will change. But if I say now load, sorry. 1 second. Let me just quickly export to PDF. So you will see what it looks like. So when I export it to PDF, and since we didn't have a very complete puzzle, that is the problem. But I'll show you a completed puzzle also. So here, when I export it to PDF, it gives me an answer. So this is the solution one, but it will also give me the puzzle one, which I can give to my students. So what my students have to do is they have to print this and cut it out. And in the classroom, they sit together and try to solve this jigsaw puzzle. This works very well for something like when we are doing revisions, so there are various concepts and what are they called? Students sit together and they kind of piece it together. And the students really have a lot of fun doing it. I'll just quickly show you a particular Tarsia puzzle that is completed so that you can see that. One second. Yes, so this was a Tarsia puzzle that we made for our this was a Tarsia puzzle that we made for our forensic science or forensic lab kind of a thing. So here, for example, I had to print this and cut out. So there were various kinds of scientists that work around for to solve a particular crime scene. So they were asked what kind of, can you put them together? So for example, analytical chemist. Now an analytical chemist basically probably will work on a colored particle is found on a suspect's clothing, and they have to put that triangle next to it such that together it forms one right triangle. So that is something that the students would love doing. I have tried Tarsia in multiple classrooms because puzzle solving is so easy for students. They love doing that. So This is, for example, a ICT based tool that is not really ICT based because it's done in person. At the same time, you could also try making like crossword puzzles. So there are various apps that can help us make crossword puzzles. I just make the crossword puzzle, I take it to my classroom for students to solve, and students love solving crosswords. So the idea here is that can we work with our students such that we use these apps to our own benefit? So many of these apps do give it a try and see which one will work best for you. I'm also sharing some of the reading resources. So these are some of the reading resources specifically for chemistry. Try these resources. Some of them will be very useful for the students. At the same time, for example, ChemEd Exchange is a blog where chemistry teachers have come together across the world and they share what works best in their classroom. So if there is a particular topic, you could search it on the ChemEd Exchange and then think about whether it works in your classroom, and exchange your notes with some other class in or some other teacher across the world. So the idea here is that when we think about the Bloom's taxonomy, we always talk about remembering, understanding, applying, analyzing, evaluating, and creating. Let us work with students' activities that work well with them. The student activities that students probably love a lot. For example, they all carry a very good cell phone these days. At least in Pune, we see that. I'm not sure whether it is seen in all colleges or all things, but they do have a good cell phone. So can we ask them to make a film or make a video on a particular concept in chemistry? And students will surprise you. They're suddenly, instead of asking them to write a particular essay or write a particular answer, you change it to making, hey, this particular reaction mechanism, can you show me via dance? Make a video on it. And students really love this change. So can we, instead of just paper and pen based interaction or a classroom chalk and board or even a smart board types interaction, can we ask them to use their ICT skills? They are wonderful at ICT skills because they are a generation that has grown with this particular resource at their hand. So ask them to make an Instagram reel, they will be happy to make it. Ask them, how, for example, for one of our assignments, which was about, titrations, right? So we were trying to teach them how to test water quality. So this is a very standard titration that happens, iodometric titration. And there, one of the things is how do you sample water, right? So we asked them, hey, why don't you go and, show us or make a video about this particular technique? So the students made a beautiful video of how sampling needs to be done. Or our second year students, when they were done with their lab, we asked them, why don't you make a video for the next batch? In the sense, when they are going to do this particular experiment, what are the things that they should take care of? So for example, if they are doing a particular synthesis, then the temperature should not rise above, then the temperature, or ensure that you have clamped your flask like this or things like that. So we asked them, hey, make a video that will be useful for your next batch of students. And these videos are still being used for every single batch, because what happens is, when I ask my students to make a video, not only that student learns, but the next batch also learns. Because this is something true when it comes to collaborative learning, is that the learners who have just learned, which is my students, when they try to teach, not only their learning improves, it's the next generation or the next, or the receiver's learning also improves. So can we think about changing our teaching such that we incorporate blogging, we incorporate video making, we incorporate podcasting, we incorporate social media blogs, making a reel, making tweet, things like that, of course with the basis of chemistry, but get them interested. And I'm sure that just like me, all of us here are new to this, but the idea here is, can we keep learning? So let us keep learning. Let us work towards making the classroom not only enjoyable with these digital tools, but also effective with these digital tools. Thank you so much. So this was Let me know if you have any questions based on the tools that we discussed today. If you try something, do share it. It's always fun to see videos made by different students, or how you are incorporating a particular tool in the classroom. So do share. Yeah.
Thank you, ma'am. Thank you so much. Ma'am, one request is there. If you could share your presentation with us.
I'll share.
Because we have to, that will be very useful for disseminate the participants. They are readily getting the resources from that particular presentation, ma'am.
I'll share the PDF of which has all these resources. So
Yeah, ma'am. Thank you so much, ma'am. Thank you so much. Yes, the participants forum is open for question, answer, or discussion. If you have any queries or the questions, you can directly ask to Nirja, ma'am. Please, Irina.
Yeah.
Hello, ma'am.
Hello. Hi.
Thank you so much, ma'am. Wonderful presentation and wonderful knowledge. Personally, I just enjoyed the session very much today. Thank you so much. I just couldn't get that one point in that puzzle maker thing. How the students, how they would be submitting that puzzle after solving, whether they will do it online or
no, so they do it in the classroom. So I wish I had one puzzle with me, but let's say if this is my puzzle and let's do it together. So I'm just going to make a quick puzzle here.
Okay, we are providing them on paper only and they will solve it on paper only.
Yes, so let's say I print this and I cut it. I give them triangles.
Okay.
Right? And what they have to do is sit together and make this big triangle together.
Okay.
Because they will have to then evaluate the question and answer of each and everything and put it together.
Okay, and they will find the solution on paper only. Okay.
On paper only, or together they will sit together and do it on the bench basically. They put those pieces together on the bench. But this is a wonderful way. I don't need a technology. I don't need anything other than a
Definitely.
printed. Yes.
Group knowledge exchange would be there.
Yeah. They have to discuss and solve. That's the idea. Yes.
Okay. Wonderful, ma'am. Thank you so much. Thank you.
Yes, anyone else?
Ma'am, it was very nice presentation. It was quite open-ended, and that's what it gives us ample opportunity to think and make our own activities, so as to make our students learn, understand, or appreciate chemistry. So wonderful, madam. Thank you. I don't have any questions. Thank you.
Thank you so much. If there are any questions, my email, I'm just putting it here in the chat box. Please share your questions. I'll be very happy to share whatever I know with you all. Yes.
Hello. Ma'am, one question regarding this PET simulation. Suppose we have some topic our own test which are teaching with. And is it there are only few videos which are shown there? We can show only those videos which are there.
So I think there are around 80 total simulations on PhET, and some of them are not there. But what you have is, that's why I showed CT STEM. CT STEM is somewhere where you can make your own lesson also. It's very easy to make a lesson on CT STEM. You might think that you would need to know a lot of coding, but that's not the thing. It's a block coding thing. Basically, I tell the block move like this, all the commands are also not given in the coding language. So in fact, they are appealing to teachers. If you wish to create a particular lesson specifically for the topic that you are teaching, go to CT STEM and make up a lesson, and that will be useful for many other teachers. But for undergraduate syllabus, most of the first year syllabus, I think there are quite a few simulations on PhET that are useful. And also try the lab exchange. So if it's more organic based, try to go for the lab exchange.
Hello.
Yeah.
I'm audible, ma'am.
Yes, sir.
Nice way you represent and new things we
Thank
came
you,
to
sir.
know today. My question is that you just shed a light on the role of TPAC to improve the laboratory teaching through virtual laboratories and the simulations.
Yes. So, okay. So when it comes to lab education, there are various things that we have to take care as a teacher. One is the hands-on skill can never be replaced with something like a digital tool, right? Because unless I really work with the glassware, pour things in from one end to another, let's say titrate, whatever it is, synthesis, I can never get the feeling of the same online. There's no doubt about it. But what I can do online is do a mock simulation. In the sense, before doing an experiment, ask students to do a live or rather a mock simulation online, because it helps to prep them for the simulation, for the actual experiment that they do. So when it comes to use of simulations, especially Amrita Vishwa Vidyapith and other simulators, try to use them before the actual experiment. Now, the thing here is that what happens is, okay, so lab experiments are like cookbook very often for our students, in the sense there is a set procedures, they have to follow the procedure, they have to then think alongside what is happening, and that never happens because the student is so focused on following the procedure, they do not have the time to think about what is happening in the flask, what chemistry is really happening, what molecular transformations are happening, and it's a very valid thing. So can we remove the load of this procedural following? If I have done it online multiple times, it becomes easier to sequentially know the steps that I have to do in person when I'm actually working in the lab. And that gives me time to observe the actual observations that I have to do in the lab. I mean, very simply, if my focus is on titration, I am never going to really make the right observations for the color change.
Yes.
But if my focus is now shifted towards not focusing on what is the next step, I may be able to focus more on the observations. Yes.
Thank you. Thank you.
Yes.
Thank you, ma'am. If you could permit, shall we conclude the session because we have to
Sure,
move on to the next session.
Yes, sir.
So now
And
may I
all the
request
best to everyone. Please share what you do. That will make us happy. Yes.
Thank you.
Yes, Dr. Wajid sir, please
Yes,
propose.
sir. Yes, sir. Am I audible, sir?
Yeah, sir.
Thank you, sir. Very good afternoon to every present here. I am Dr. Mohammad Wajid Sheikh, Assistant Professor, Department of Chemistry, Yashandra Chavan Arts and Science, Mahavidyalaya Makrulpir. It is my proud privilege to propose the vote of thanks for today enriching session of the refresher course in chemistry organized by Malviya Mission Teacher Training Center, Sant Gadki Baba Amravati, University Amravati. First and foremost, I express our heartfelt gratitude to our esteemed resource person, Dr. Nirja Dashaputre Madam, for delivering such insightful and inspiring lecture. Your profound knowledge, scientific approach, and lucid explanation of topic have greatly enhanced our understanding and stimulated our curiosity. We sincerely appreciate the time, effort, and expertise you have shared with us. I extend my sincere thanks to Director and Coordinator of MMTTC, Sant Gadki Baba Amravati, University Amravati, for their visionary leadership and for organizing this valuable academic program. My gratitude to also goes to organizing committee and the technical support team for ensuring the smooth conduct of today's session. I would also like to thank all the participants for their participation, thoughtful questions, and active interaction, which made this session highly engaging and meaningful. Once again, on the behalf of Malviya Mission Teacher Training Center, Sant Gadki Baba Amravati, University Amravati, and all the participants, I extend our sincere gratitude to our respected resource person for sharing valuable knowledge and inspiring us through this excellent session. Thank you all for your gracious presence and participation. Have a wonderful day. Thank you, sir.
Thank you.
Thank you, Dr. Nirja ma'am. Thank you. And with the kind consent of Dr. Nirja ma'am, I would like to declare that this session will be over here. Thank you so much, ma'am.
Thank you. Yes.
Hello, Professor Umre sir.
Yes.
Sir, extremely sorry. We have taken the 10 minutes from your allotted time.
Okay, doesn't matter. Yeah.
So shall we start with the session, sir, if you could permit?
Yes, yes.
Yeah, so good afternoon, friends, once again. First of all, I extend my warm welcome to our esteemed expert, Professor Suresh Umre sir, to this session, as well as to this refresher course on behalf of Malvi Mission Teacher Training Centers and Gadge Baba Amravati University and all the learned participants. And now may I request Dr. Naresh Kumar sir to please introduce our guest in brief, and then we will start with the session. Yes, Dr. Naresh ji, please.
Thank you, sir. Am I audible, sir?
Yeah, sir, very much.
Yes.
Good afternoon to all. Myself, Dr. Naresh Kumar, working as an assistant professor chemistry in the Department of Applied Sciences at Hembati Nandan Bahuguna Garhwal University, Srinagar Garhwal, Uttarakhand. First of all, I would like to express my sincere gratitude to UGC MMTTC Sant Gadge Baba Amravati University for giving me the opportunity to welcome and introduce our esteemed resource person, Professor Suresh S. Umare sir. On the behalf of UGC MMTTC Sant Gadge Baba Amravati University and all the participants, I extend a warm welcome to you, sir. Sir, we are truly honored to have you with us on this virtual platform of refresher course in chemistry, and it is my privilege to introduce Professor S.S. Umare sir, who is presently serving as Professor Higher Academic Grade in the Department of Chemistry at Vishwesvaraya National Institute of Technology, Nagpur. Professor Umare sir obtained his MSc, MPhil, and PhD in chemistry from Nagpur University. His academic journey also includes international research experience at Sheffield Hallam University, UK, under the UK-India REC bilateral project, followed by postdoctoral research at IIT Kanpur. Professor Umare sir research area includes solid-state chemistry of polymers, nanomaterial science, heterogeneous nanocatalysis, and green chemistry. He has successfully completed 5 major research projects funded by leading agencies including MHRD, UGC, MEC, BRNS, and DST, and published nearly 95 research papers, including book chapters in reputed international peer-reviewed journals, and has authored 2 books. Sir has guided 18 PhD students and also served as reviewer for several prestigious scientific journals. Professor Umare sir has delivered more than 80 invited and keynote lectures at national and international platforms in recognition of his outstanding contribution to science and education. He has been elected as Fellow of Royal Society of Chemistry UK, the Indian Society of Analytical Scientists, and the Maharashtra Academy of Sciences. Along with his excellence in teaching and research, he has also performed several important administrative responsibilities at VNIT, including as head of department, member secretary for the formulation of the chemical engineering program, coordinator of FIST program, chief warden, and dean of student welfares, etc. Sir, your distinguished career, remarkable achievements, and unwavering commitment to scientific research make you an inspiration to the academic community. I am confident that your lecture on green chemistry and sustainable development will be highly informative and inspiring for all the participants. Now, without taking much of your valuable time, I request Professor Umare sir to kindly deliver your enlightening lecture on green chemistry and sustainable development. Thank you, sir. Over to you, sir. Sir, please unmute yourself.
Are you able to see my slides?
No, sir.
Yeah, okay. Are you able to see my slide now?
No, sir.
Hello.
No, sir, it's not visible.
এটা কোন ল্যাপটপে
Yes, sir. Now it is
যাবে রে
visible.
Okay,
তবে
okay,
একটু সরানো যাবে রে
Thank you, sir.
একটু সাইড করে রাখালেই হবে এখানে রাখিস না কেন বসবে স্টুডেন্ট
Mitali
খোলা
Sen,
যাবে
Mitali Sen, ma'am,
মানে
please
চার্জ
mute
চার্জের
yourself.
দরকার নেই তো
Hello, Mitali Sen, ma'am, please mute yourself.
চলে আসো তাড়াতাড়ি চলে
Okay,
আসো
is it audible now? Hello?
Sir, yes, sir,
Yes, sir.
audible.
Yes, sir. Yes, sir.
Yes.
And you are able to see my slides also?
Yes, sir.
Is,
Yes, sir, visible.
is it moving?
Yes,
Yes.
yes, sir.
Yes, sir, yes, sir, moving.
Okay, okay, okay. Thank you, thank you. So, thank you. Thank you for kind introduction. My presentation, this is on the green chemistry and sustainable development. I think this is one of the course that is taught in the UG as well as PG program. I think here in these participants are all teachers. Is it right? Hello?
Yes, sir.
Okay.
Yes, sir. Yes.
Right. So let us start this green chemistry and this sustainable development. Everyone knows this green. It is the term used basically for environmental awareness. And we know the green, we have a national flag and we have a different colors in national flag, and green color, it is at the bottom. It is basically indication of a growth and prosperity of the country. So similarly, the green chemistry, it talks about basically the prosperity of a chemistry, growth of a chemistry. And you are all, I think, chemistry teachers. And the chemistry, you know, it is nothing but the basically study of the composition of a matter and its structure and its interaction with each other. And sustainable development, basically, it is nowadays, this term is used, how this chemistry become, one can make a sustainable. There are different issues we are going to discuss. So this chemistry, the problem it is from the chemistry and how one can make it a sustainable one. Sustainability, it is nothing but the development which meets the needs of present generation without compromising the ability of future generation. We know the future generation, the ability, the requirement may be different. So looking into that aspect, how that can be managed and chemistry that can be developed. So today we know we are all scientifically developed, economically developed, technologically developed. Everybody, we are having today cell phone, right? Today we are talking maybe different distance. You are a different distance. I am talking with you. We have an internet and we can able to talk. So we are scientifically developed. Today we are more than $4 trillion economy, and we are struggling for $5 trillion economy in order to become the economically third economically country in the world. Today, again, we know we are technologically developed, and advancement of technology, it is depends upon the kind of the material used in that technology. So success of a technology depends on the kind of the material used. And we know the technology, it is nothing but the outcome of the science. And using this technology today, we can go to the moon. We can send our mission to the Mars. So friends, we are all aware about this technology development. We have a industrial revolution in 18th, 19th century. We had an industrial revolution. There is a production, lot of production, different kinds of the goods we able to produce. Then, you know, in 1965, we have a green revolution. We have a famine, basically a lot of the food shortage. And during that time, Professor Swaminathan, he considered as a father of green revolution. And we had a development of fertilizers, pesticide, preservatives, so that they can be stored for longer duration. Then we have a white revolution. Then there is a lot of development of advanced material. Today we have a lot of advanced material that is used for different advanced technology, the polymer, the composite material, the glasses, right? So, so that is developed. Then we have a life-saving drugs. Today, a lot of drugs that has been developed, and the live different diseases that can be cured, and average lifetime today it is 72 years. In 90s we have hardly the average life, it is 42 years. So these are all the chemicals basically. So we can say the chemicals has enhanced the quality and comfort of the life. We know the basically, but because of this chemical, these chemicals are used excessively. We know the fertilizers, a lot of fertilizers are used, excessive pesticides are used, lot many drugs that has been invented, and these drugs we use heavily. Again, the fossil fuel we use, a lot of solvents we used, the coolant, the refrigerant, a lot of different chemicals we use, and we use different chemicals heavily. We know there is a lot of the newses. There is a use of some pesticide as a preservatives in excessive form, more than the limit which is prescribed by the government. So it is a toxic, it become a toxic. There is a overuse, consumption of the different natural resources. Maybe the fuel as a resource, the different coal or a natural gas. Heavily we use the timber, heavily, the ores, the minerals that is used. And as a result, because of this excessive use, we have a different issues, the global issues. We have a regional issues. We are aware about these all issues, the global warming, climatic change, ozone depletion, acid rain, the local issues, the different kinds of pollution, air pollution, water pollution. Then we have a very poor air quality index. We will be discussing some of the facts. There are a lot of the chemicals which persist in the environment for longer duration, and that's called it as a persistent organic pollutant. So basically all these are all issues. It is because of the different kinds of the chemical, excessive form of the chemicals we used for different application. Then there will be a question, why to care for pollutant and the environmental issues? These are the different issues associated with it. So why to care for the pollution and maybe the CO2 emission? There is a lot of, the greenhouse gases that is emitting, the fuel is burning, and the byproduct of the fuel, it is the CO2. So persistent organic pollutant, or they are non-degradable, having the property. They are having carcinogenic property, mutagenic property, teratogenic property, causes the acute and chronic toxicity. CO2 contributing to global warming and climatic change, and more global heating, ocean are warming. There is a shrinkage of the ice cap, and the frequent there is a forest fire. There is a rise in the sea level, coastal area become more vulnerable, and there is a extreme weather event, and intensity of the weather event, it is increasing. Today, there is a flood somewhere, there may be some drought somewhere. The frequency of the floods, it is increasing. The frequency of the storm, it is increasing. In this presentation, I have not given data, but the report says there is an enhancement in the intensity as well as the frequency of this natural event. We know the development of a green chemistry. So there is initially some of the people, the developed country people, they come together and they work basically and to find out the chemical which are sustainable nature and how the chemical can be made sustainable. There is a book in 1962 published by Silent Springer. It is by Rachel Carman. This is gives mostly about the use of a DDT, which is highly basically persistent organic pollutant, used heavily in earlier days, and that has a bad effect on the birds as well as the insect. Then in 1972, there is a first human conference that is on the human environment, and later in 1992, first Earth Summit that is in Rio de Janeiro, Brazil, to create a plan for international action on environmental development. And outcome of this conference, it is the Agenda 21. It is an action plan for sustainable development in 21st century. And there is a establishment of a United Nations Framework Conference on Climatic Change in 1944-94 to stabilize the greenhouse gas emission. So the development of a green chemistry, it is basically all these issues are because of the chemical. Different chemicals we used, and chemicals, they show us the bad effect because of excessive use. So in order to make the chemicals safer, in 1919, learned people started working as a mission and to make the chemistry and chemical safer, hazardless to the maximum extent. Then in 1991, the term green chemistry was introduced by Professor Paul Anasta. He considered as a father of green chemistry. Then in 1997, Professor Paul Anasta and Professor John Werner, he gave the 12 principle of the environmental friendly chemistry, which is called it as a green chemistry. So how we can define the green chemistry? So green chemistry, it talks about pollution control, different kind of a pollution, air pollution, water pollution, land pollution, at a molecular level, at a small level, atomic level. You know, the molecule, it is made up of the atom. So pollution has to be controlled at an atomic level. There should not be wastage of the atom. So it is at the source. It is at the source means it is in the beginning of the process. We know the process. We produce a product, we develop a product, and for development of a product, the process is involved. So we have to think pollution control at the beginning of the process. At the source means at the beginning of the process. During the designing of a chemical product, while designing a process, one has to design in such a fashion that the pollution can be controlled at the beginning, at the source itself, at the beginning of the process itself. And the process using new innovative approaches. Green chemistry promotes the minimization of waste. You know, in a chemical reaction, in a process, there is a generation of a byproduct, and most of times the byproduct, it is of no use, so we considered it as a waste. This waste may having a property, different properties, hazardous property. There may be having a risk associated with it, energy consumption in the process, cost involvement in the product synthesis, environmental impact. So these are the various factors which is taken into consideration. So green chemistry promotes the minimization of waste, hazard, risk, energy, cost, and utilization of catalyst. We know the catalyzed process, non-catalyzed process. As a chemist, we understand the catalyzed process, it is an energy efficient process. We'll be discussing under the principal catalysis, use of a catalysis in details about use of a catalyst. Non-toxic reagent, what are the chemicals we use, the solvent we use. Most of the solvent, they are toxic in nature. So can we replace the toxic solvent with the non-toxic solvent? So this is the second definition of a green chemistry. Again, the green chemistry that can be defined promotes the innovation in product, process, technology, or sustainable development. There may be some process. One process already may be in existence for the product development. Can we innovate another process, another technology, which will be having, which will be of less hazard in nature, energy efficient process, environmental friendly process. So one can innovate the different process. So these are the different basically definitions we can define in a different ways. So this is the first principle. The Professor Paul Anasta and John Werner in 1997, they have given the 12 principle of a green chemistry. And if we use this 12 principle of a green chemistry to some extent, we can make the process safer, the product safer. So this is the first principle of green chemistry, which talks about prevention of waste or a byproduct. We know this is a simple reaction. A plus B, these are the reactant. It gives a C, and D is the byproduct. C is the product. This product, it may be a tonic, it may be a vitamin, which can save the life of a patient. But at the same time, there is a generation of a byproduct, and this byproduct, it may be a toxic, which can kill the life of the people. So this is one reaction. This is the second reaction, where there is no generation of the byproduct. So only product that can be developed. So the people, as a chemist, one has to think this kind of a process where there will be no generation of a waste, there will be no generation of the byproduct. So the management, we know the byproduct, it is to be managed properly. If it is a toxic, it has to be managed properly, it has to be disposed properly. There is economy involved in it, there is energy involved in it, manpower involved in it. So one has to develop the process where there should not be a generation of the byproduct. As a chemist, one has to work on that kind of a process where there is no generation of the byproduct. So this is a simple one process. We know the sulfur, there is a presence of sulfur in a coal, and coal is heavily used for power generation in a thermal power plant. And coal, when burned, there is an emission, sulfur dioxide as an emission as a byproduct. There are different emissions other than sulfur dioxide. Carbon converts to carbon dioxide. Here only in thermal power plant, they utilize the heat converting heat. It's utilized in order to convert the steam and generate the electricity. But the other byproduct, we talking about only one component, that is the sulfur. So sulfur, it is when it is burned, it emit in the form of a sulfur dioxide, and that sulfur dioxide, it causes the acid rain, different kind of a pollution. It is a pollutant. So this pollutant one can avoid by removing the sulfur before utilizing the coal by the various process. One process, it is a microbial desulfurization process. This is basically microorganism, thiobacillus bacteria. They were eating the sulfur, and one can get a sulfur-free coal, and that can be utilized for thermal power plant, for the steam generation, the electricity generation, so that one can, there will be no emission of sulfur dioxide into the atmosphere. So this is the simple example I'm trying to give in order to avoid the byproduct formation. The second principle talks about the maximization of atom economy. Basically, atom economy, we know atom. There are 118 elements in a periodic table, and this atom economy management of the atom in a product. If we are a chemist, we know the calculation of the yield calculation. This is the formula used. Calculation of the yield, actual quantity of the product achieved by theoretical quantity of the product obtained into 100, that gives the percentage yield. But here there is no consideration of any byproduct. There is a generation of byproduct in many syntheses, but in calculation of percentage yield, we don't take into consideration the percentage, the byproduct form. So though the percentage yield is 100%, but there is a byproduct formation which we don't take into consideration. So green chemistry doesn't talk about the percentage yield. It talks about the percentage atom economy. So this is the formula used for percentage atom economy. It is the molecular weight of a desired product by sum of the molecular weight of the reactant into 100. So in this way, here the atoms involved in the reactant, all the atoms involved in the reactant, it is taken into consideration, so that there should not be a loss of an atom. If a loss of the atom means the atom economy may not be 100%. Atom economy, it will be less than 100%. So these are the reactions. This is addition reaction. We are aware about the addition reaction. Since we are all chemists, so we are aware about the rearrangement reaction. In addition reaction, only all addition of the reactant that is going to occur, and one can get 100% atom economy. Rearrangement reaction, only rearrangement of the atoms that is going to occur. There will be no losses, so it will give again 100% atom economy. In a substitution reaction, elimination reaction, some group it is get eliminated, some group it is get substituted, and there may be a formation of a byproduct, and that byproduct which is due to formation of the byproduct, so atom economy of a complete process, that will be less than 100%. So addition reaction, rearrangement reaction, it is 100%. There is no loss of the atom, so atom economy is 100%. Atom economy is less than 100% in substitution reaction, elimination reaction. So this is one of the product, that is a Brufen. This is a painkiller. This is developed by one company that is called it as a Boost company. This is an old company in 1960, and there are 7 steps involved in these 6 steps involved in this product synthesis, Brufen, and atom economy of this process is 40%. The similar product, it is developed by BHC, the Bharat Hindustan Chemicals, 1992, and within these 3 steps, the same product that was developed, and here atom economy is 70%. The 3 steps are involved. So atom economy is high. The loss of the atom, it is less in this next process. So maybe the product form, this product, it is we can say the energy efficient product. Since the steps are less, maximum atoms are consumed, atom economy is high compared to compared to the earlier process. So it is an energy efficient process. So green chemistry talks about the energy efficient process and more atom economy of a process. There is another concept called it as a environmental factor. Is it going on well? Is it audible, everything?
Yes, sir.
Yes, sir. Yes, sir.
Okay. So this is another concept explained by the green chemistry, talks about the environmental factor. In a atom economy, this is a basically theoretical aspect for calculating the atom economy, right? There may be some solvent used in a atom economy process, maybe some catalyst used in a atom economic process, which is not taken into consideration in case of the atom economy calculation. But in the calculation of environmental factor, it talks about the total waste generated in a process by the total weight of the product generated. So this gives the actual idea about the environmental effect of the process. So there are many industries, the oil refining industry, bulk chemicals, fine chemicals, pharmaceuticals, and they produce their product in tons per year. And this is an environmental factor, E factor. For oil refinery, the waste generation is very less. For pharmaceutical, however, the waste generation is very high. So pharmaceutical process, maybe the we can say the environmental factor is very high, and the lot of steps are involved, and the lot of waste is generated. So they are not the environmental friendly process. Since the E factor is high, so this process we considered as a not environmental friendly factors. So this is basically difference between atom economy and E factor. It considered the starting material and the desired product in atom economy. However, it provides a true ecological footprint of a process by penalizing the use of toxic solvent and catalyst, which is ignored in atom economic process. So atom economic process, this is empirically based on fit into the life cycle assessment, and it is a simple theoretical aspect. So what are the benefit of the atom economy and E factor? There is an increase in the product yield. You can say it is a increase in the what you call the atom economy E factor of the process. Less waste generation, less energy required, improved product cost. So this is a third principle of a green chemistry, which talks about the minimization of hazard. Hazard means any chemical, physical condition that causes potential damage to property, health, or a environment, that causes the hazard. We know there are some, explosion. Explosives are used, and explosives, when there is an explosion, there is a physical damage, there is a release of some gas, there is a chemical damage, there is a loss of life, loss of the property, and again, the loss of the environment. So this is one of the example chemical reaction hazard. This is called it as a chemical reaction hazard. And we discuss about the different kinds of a reaction. We deal as a chemist, we deal different process, maybe the addition process, substitution process, elimination process, again, the hydrogenation process, sulfonation process, polymerization process, halogenation process. There are different processes we come across. So which process can be a hazard process? Some processes are exothermic reaction involved or exothermic reaction. And we know in an exothermic process, there is an increase in the temperature. Rate of the reaction, it is get increased. And this rate of the reaction increases, again, it adds the heat into the system. If the system, it is a closed system, there is an addition of heat, accumulation of heat into the system, and further there is a increase in the rate of a reaction. Further, there is a emission of heat, and many times, if there is a the control, if it is not proper, then the accident that is occur, the explosion that is occur, that is called it as a thermal runaway. There is a survey, and in a survey it was identified that there are many processes we chemists come across: the acetylation process, sulfonation process, what called the halogenation, salt formation, hydrolysis, esterification. So among this process, polymerization process, it is considered as a most hazard process. The control on the heat dissipation is very bad in this kind of a process, and a lot of accident that was identified in a polymerization process, and this is considered as a most hazard process. The hazardness of a molecule, again, it can be estimated by the oxygen balance. We know the different element present in the molecule, vulnerable. Which molecule can be a more vulnerable? We know some explosives. Simple example, ammonium nitrate. It is used as a gunpowder. Again, we know the tetranitrotoluene. This is again explosive. So there is the presence of the element. So how much amount of elements are present? This is the formula used. 2x plus y by 2z minus m. So x, y, z, m, this is nothing but the number of atom of carbon, hydrogen, oxygen, metal present in that particular molecule. If you substitute the number of present atom in that particular molecule by molecular weight of the compound, that molecule, one can get a oxygen balance. And if oxygen balance is more positive than -200, it is treated as a potential high risk molecule. If it is less, then it will be considered as a less risk. So in this way, one can identify the molecule, hazard molecule, or the different kinds of a process. So these are the benefits of the basically third principle, minimization of hazard. One can inherently safer process, improve the work safety in the process, reduction in the hazard waste. So this is again the fourth principle of the green chemistry, which talks about the use of this safer chemical. You know, large number of the chemical we used in everyday life. This is one of the chemical. I have taken one example. This is a tetrachloroethylene, and this is a chlorine-based molecule. It has a global warming potential. Basically, it is a greenhouse. The vapors are emitting, and this is act as a greenhouse gases. And this is contributing to global warming, as well as there is a liberation of a chlorine, maybe at a stratospheric level. And this is, it gives the chloride radical. That chloride radical destroy the ozone depletion, ozone layer. So it is contributing to global warming. It is contributing to ozone depletion, as well as it is highly volatile. This volatile, when it is exposed, the people is exposed, it has got again the bad effect on the human health. So this is a use as a dry cleaning application. So this common chemical which is used for dry cleaning application, that can be replaced with the other chemical which is of non-toxic in nature. You might be knowing the supercritical CO2 that is can be used nowadays for cleaning application. Supercritical CO2, this is a basically phase diagram of a supercritical CO2. The CO2, it is a gas at normal temperature and pressure, but at a supercritical state, means at certain temperature and pressure, critical temperature 31.1 degrees centigrade and critical pressure 72.8. Above this temperature and pressure, the CO2, it has both the kind of the property. It has a fluid property. We call it as a fluid property. So it has a gaseous property as well as it has a liquid property. So diffusivity will be high, and effect whenever it is used, this solvent it is used, it will be gives a better product, better yield, rate of the reaction, it is a better. So that is an advantage compared to the conventional chemicals we used for the different application as a safer chemical. This is a fifth principle of a green chemistry, which talks about the selection of a appropriate solvent. We know large number of the chemical we used for different process, for analytical chemistry, for purification, crystallization, for coating application, cleaning, for extraction. So a lot of the different chemicals we used. What chemical we use? We use the benzene, toluene, or a xylene, or a methyl cyanide, DMSO, DMF, DHF. And this is basically all these chemicals, they are basically having a bad effect. Some chemicals are carcinogenic, they are cancer producing suspect. Some chemicals causes the cataract, some are irritant, some are causes the birth defect, nausea, headache. So these are the different properties. But we know this is the basically property given by the chemical industry, the Merck. We aware about the Merck Industries. They are producing all these solvent. They have given these properties. And the toxicity, it is associated with the exposure. As a teacher or as a student, when we work in a laboratory, we work in a laboratory for a short duration. And we deal the chemical, the solvent, maybe in a very small quantity, maybe 10 ml, 20 ml, maybe the 100 ml. But in an industry, these workers, they expose with the minimum 8 hours duration. Daily, they have to work the same kind of the chemicals or a different kind of a chemical. And they deal with the gallons of the chemical. The amount of exposure is very high in an industry. But in a research laboratory or in a laboratory where we perform the experiment, we come across a very small quantity of the chemical. So toxicity, it is very less in a laboratory because our exposure period is very less amount of solvent we come across. So the risk is very less. But in industry, the same solvent, when it is used, the toxicity that will be high. What are the different bad effect of it? There are some direct issues associated with this solvent. They are volatile in nature, they are flammable in nature, they are carcinogenic, and they causes the ozone depletion, global warming, the smoke formation, the ozone formation. There is a formation of a ozone. It is troposcopic level. We'll be discussing how this ozone in a stratosphere it is different, ozone in a troposphere is different. There is a depletion of ozone from the stratospheric ozone and formation of ozone in a troposphere because of use of this solvent, volatile solvent. So we'll not go the history associated with it. Basically, we know there are some solvent we use and they are chlorine based. They are contributing to the global warming as well as the ozone depletion. And this solvent, the chemicals, the solvents are highly used, and because of that there is a ozone depletion. Ozone hole, there is a discovery of ozone hole in 1984. And in order to protect the ozone hole, there is a establishment of a Montreal Protocol for protection of ozone layer. And these are they also identified the different 100 chemicals like the CFC or halon, which can be banned from the consumption as well as the use in particular application. Then there is a different, again, the protocol that is called is the Kigali Protocol. There is a Montreal Protocol which is used to protect the ozone depletion, ozone layer. We know the CFC, this is used as a one of the chemical, chlorofluorocarbon chemical in a coolant, as a coolant for a refrigeration application. But looking into its ozone depletion potential, there is a change in the transition from use of a CFC chlorofluorocarbon to hydrochlorofluorocarbon, then to the hydrofluorocarbon, and then hydrofluoroolefins. This is an example of a hydrofluoroolefin, which is having the global warming potential very less, as well as the ozone depletion potential is less. So nowadays, the CFC no more it is used for coolant application or a refrigeration application. Nowadays, there is a use of a hydrofluoroolefin. So replacing the chemical, old chemical by the new chemical, which is having a very less global warming potential and zero ozone depletion potential. And there is a, you might be heard, there is a, again, because of the two different event, the smoke disaster. It is a London smoke disaster. It is occurred in 1952. These are the two different accident occurred at different places. This is in London in 1952. It is because of the heavy burning of a coal. There is a emission, lot of emission, and that is called it as a gray smoke. You know, the emission, the smoke, it is generated, the word generated from the smoke and the fog. We know the fog, the water droplets which is suspended in the water. That fog interact with the smoke and it gives the smoke. That it is a disaster. It is a London smoke disaster. There is it is a stagnant, since if the wind is not blowing, if the wind is stagnant, then whatever the emissions occurred, that emission will remain in that particular area, and the people were inhaling that smoke gases. The content will be, the coal contained the sulfur, it converts to sulfur dioxide, then the sulfuric acid. People were inhaling these vapors and they are damaging the respiratory system. The particulate matter, again, it causing the respiratory diseases, and there is a lot of death. 12,000 dies in this London smoke disaster. This is a Los Angeles smoke disaster in 1942. This Los Angeles smoke disaster, it is again due to formation of a smoke, but this is a different kind of a smoke. Here, London smoke disaster, the smoke, it is from sulfurous based smoke. Here, it is a nitrogen based smoke. Basically, there is a heavy use of the automobile. And in a combustion process, there is an emission of nitrogen monoxide and converts immediately to nitrogen dioxide. And this nitrogen monoxide, nitrogen dioxide, it is brown color. It is in brown color. So the smoke colored is the brown smoke. This is again a toxic. There is a generation of a ozone here in this process. It is a tropospheric ozone. And this ozone, again, it is a toxic. And there is again the different kinds of the respiratory issues that arises, asthma or basically the chronic bronchitis, eyes irritation. So different kinds of the diseases that has occurred because of the generation of a smoke. So the green solvent, what can be the green solvent? This is because of, these are all issues because of the use of a traditional solvent, which is highly volatile in nature. The chlorine content is high, they are flammable, they are volatile, and there is a generation of a smoke. The London smoke disaster or a Los Angeles smoke disaster. And this is a basically the green solvent. What are the green solvent? We discussed earlier the supercritical water as a solvent. The supercritical water, the water, it is at supercritical temperature and supercritical pressure. Similarly, we can have a supercritical water, supercritical CO2, supercritical water. Supercritical water, we know the water exists in a different phases: liquid water, solid water, solid, that is we called it as a ice, liquid, gas, vapors, water. And again, water, it is in a supercritical water. Above certain temperature and pressure, water can exist a supercritical state, which can having a different property, and that can be used for various application. So replacing the conventional solvent by supercritical CO2, supercritical water, or by ionic liquid, ethyl lactate, that can be used for different application. So green chemistry, it is basically, one can talk about the green chemistry. It can be basically talk about the solventless reaction. One can basically, the no solvent can be used, and this is some of the example where one can perform a process without any solvent. There are some process one can replace the solvent. Here, basically DMSO, that was the solvent in an ordinary process, but this process, the esterification process, that can use the water as a solvent. So we'll not discuss much of this example. So we'll discuss about the different principle. So I will skip this example. Then again, the ionic liquid, the ionic liquid, it is a simple ionic liquid. The ionic liquid consists of a organic cation, inorganic anion. The ionic, the salt, normal salt, the sodium chloride or a potassium chloride, we have a salt, but temperature, melting temperature is very high. But ionic liquid, it has a melting temperature less. It is in a liquid state at room temperature, and that can be designed by selecting the organic cation, organic, inorganic anion, and one can prepare the different ionic liquid, and that property, one can vary the anion on cation, and one can vary the property, hydrophilic property, hydrophobic property. So this ionic liquid, called it as a designer solvent. One can prepare the designer solvent, and one can use it for different application. This is a ionic, one of the example that I have showing. This is a ethyl ammonium nitrate. This is a organic cation. Inorganic anion nitrate, it's inorganic anion. And this is a binary ionic liquid, the aluminum trichloride, and the N-alkyl pyridium. This is a chloride. This is act as a binary ionic liquid. I will skip this example. So this is so far we have seen about the 5 principles of a green chemistry. This is a 6th principle of a green chemistry, which talks about the maximize energy efficiency. So we know the energy, it is required for all the process. As a chemist, we perform, in a laboratory cooling, in an industry again cooling, or a sterilization, distillation, maybe compression of a the component, different component, pumping of a solvent, separation of the product, and for all this purpose the energy is required. What is the source of the energy? Basically, it is a carbonaceous fuel, and when carbonaceous fuel burn, it emits CO2 into the atmosphere, and the CO2 comes into the atmosphere, causes the global warming and the climatic change. What are the different, basically, energy source we use? Just 1 minute. It is going on well? Hello?
Yes, sir. Yes,
Yes, sir.
It is audible. Okay. Okay. So these are the different energy sources we use. In olden days, we have a biomass. We started using coal in 1850. Then there is an addition of oil. There is an addition of gas. Today, we are using coal, oil, gas, as well as the nuclear, hydro, wind, biomass. But still, this coal, oil, and natural gas, 70% of it today it is using. Hardly less than 30%, we are using other resources. And when this carbonaceous fuel, when it is burned, it gives the energy, we utilize energy, and CO2, it is emitted into the atmosphere, and it is like a waste. It is accumulating into the atmosphere. It is accumulating. It is a colorless, it is a odorless. We can't able to see, but the effect, today we see the effect of it. We are going to discuss what is the effect. So there is a transition in shift of a different fuel. The coal, we replace with the diesel, then it is replaced with again gasoline, then LPG, CNG, and today we are looking for a hydrogen as a fuel. In this transition, basically what is happening, basically the amount of carbon percentage, it is reducing. Carbon percentage is reducing, so that emission, CO2 emission, that can reduced. So this is a carbon cycle. We know the carbon cycle, there is a CO2 emission by different process, by industrialization, by combustion, and this CO2, there is a use of a fossil fuel, and CO2 is emitted. CO2, it is absorbed by the plant. It is by the forest. And, this forest absorbing the CO2, and this is a process. But today, the CO2 emission is increasing. CO2 is emitted at a very fast rate, and absorption, it is become a slow process because of the deforestation. Because of industrialization, emission of a CO2, it is become a very high rate. And because of deforestation, the absorption of CO2, it is become a slow process. And because of this, there is a thermodynamic imbalance into the atmosphere. And CO2 is increasing day by day. This is a curve, called it as a killing curve. This is a laboratory, NOAA Global Monitoring Laboratory. It is in California. It is monitoring the CO2 continuously into the atmosphere. Today's, the January 26th, the CO2 concentration, it is 428.6 ppm. And this is the different country, China, it is the topmost country emitting CO2 into the atmosphere. Next come the United States, and then the India. It is the third largest country in the world emitter of a CO2 into the atmosphere. What is the property of a CO2? As a chemist, we know CO2, it is a colorless, it is a stable molecule, it is a odorless, which is having a global warming potential is 1. But the lifespan, it is very large, it is 100 to 300 years. And this remain in the atmosphere for 100 to 300 years. Whatever the CO2 we emit today by different process, maybe by combustion process, used maybe for cooking, maybe we are emitting CO2 by our respiration process, different process, CO2 it is emitted into the atmosphere, that is going to remain for 100 to 300 years. Though the global warming potential for CO2 is 1, there are other greenhouse gases which is having global warming potential more, but still we bother about the CO2 because CO2 amount we are using at a very high rate and concentration of a gas is very large compared to the other gases. So we are bothering more about the CO2 compared to the other greenhouse gases. Though the other greenhouse gases having a more global warming potential. So in order to tackle this global warming issue, climatic change issue, the UN, the United Nations, it is United Nations, Union of the Nation, the headquarters it is at New York, and there is a first conference at 1972 on the human environment, and there is a first Earth Summit, and there is this is a slide I think repeated earlier also, we have this similar slide. So due to this global warming, in order to tackle the CO2 emission, there is a protocol, international protocol. UN initiated the protocol, called it as a Kyoto Protocol. It is formed in 1997 to stabilize the greenhouse gases, how to reduce the greenhouse gases. So the outcome of this Kyoto Protocol, it is the developed country committed to reduce greenhouse gas emission by 5.2% during 2008 to 2012. And it introduced the carbon credit system. Carbon credit system means it is a carbon absorption system. There is a carbon absorption. So there is a different, again, the amendment in 1912, there is a Doha Amendment, and by this Doha Amendment, it is said to reduce the carbon emission by 18%. By Kyoto Protocol, it says the emission has to reduce by 5.2%. By Doha Protocol, it says about one has to reduce CO2 emission by 18%. Again, we have a Paris Agreement, and we know there is a rise in the temperature. Global temperature is increasing. Earth temperature, as per the report, it is said that already the Earth temperature is 1.5 degree more compared to pre-industrial period, 19th century, 18th century. So the this Paris Agreement, this is the outcome of a Paris Agreement, and they talk about the global temperature rise below 2 degrees centigrade. One has to keep the global temperature below 2 degrees centigrade to provide financial technical support to the developing countries, reduce CO2 emission by 20%. So these are the different protocols in order to reduce the CO2 emission, to control the global warming and climatic change. So one of the protocol, it is a carbon credit. Kyoto Protocol introduced the carbon credit. It is basically a carbon absorption capacity. So this can industry, there is a, suppose this is an example I have taken. If a factory emitting 1 lakh ton per year CO2, then permissible limit is 18,000 ton per year. So factory has to purchase equivalent carbon credit. Means for extra emission 20,000 ton per year, they have to purchase the carbon credit. So it is basically a carbon absorption capacity. This is explained in this slide. It is basically the carbon absorption. This is a carbon credit. Suppose a country is having a more forest is absorbing the CO2, carbon dioxide. The plant absorb the carbon dioxide, and industry emitting the carbon dioxide. So this pollution that can be sell in the market, countries having more absorption capacity, CO2 carbon absorption capacity, they can earn the carbon credit. In turns, they earn the some money. They sell the carbon credit to the industry. In turn, the industry, they will be purchase the carbon credit from the country which is having the more forest. So this is basically one kind of a mechanism. So the country which is having the more forest but less industrialization, they can sell their forest. Means they can sell the forest in terms of a carbon credit, and in terms this industry, they can emit the more CO2 into the atmosphere. It is a kind of a permit to emit more CO2 into the atmosphere by a particular industry or a particular country. You know, some country or advanced country, the industrialized country, the Japan or even a USA, Germany, so they can buy, they have a less forest, so they can buy the carbon credit from the country from they are having a more carbon credit, and in turn they can earn the they can sell the carbon credit. So this again, I will skip this. Basically, we will discuss more about the process. I will skip this synthesis. What are the energy efficient process? This I will skip. I will come to the 7th principle of a green chemistry, use of a renewable resources. You know, the 6th principle, it is about the use of a energy efficient process. And there are various energy efficient process. One, just I will talk about the energy efficient process. This is one of the energy efficient process. We know the microwave heating. Basically microwave, that is the electromagnetic radiation is used in order to heat, generate the heat, and that is a energy efficient process. It consumes a very less energy, and it is considered as an energy efficient process. It work in a different principle of electromagnetic radiation. It is generating, interacting with the polar solvent, the polar solvent orientation that is going to occur, and there is a heat generation, and we utilize the heat for different purpose. The industry, some of the industry, they are utilizing the using the microwave oven for the industrial process. It is, since it is an energy efficient process. So that 6th principle talks about the energy efficiency, maximization of a energy efficiency. 7th principle, it talks about the renewable resources, use of the renewable resources, use of the basically green resources, which can renewed frequently within a short span of a time. Quickly, we'll see this principle. This is a petroleum industry. This is a biotechnological industry. So this is a biomass can be converted into the fossil fuel, and fossil fuel further that can be used, which is called it as a sustainable process. Since there is a no net CO2 emission into the atmosphere, while in a non-sustainable process, the today's process, petrochemical industry, it is using the CO2, the fuel we are extracting from the earth crust, and we are utilizing, emitting CO2 into the atmosphere, releasing CO2 to the atmosphere, and for formation of a fossil fuel, it takes millions of years. So we called this petrochemical process, it is a non-sustainable process. And biotechnological route, it is a sustainable process. So one can develop the different kinds of a product, biodiesel or a bioalcohol, biogas, syngas, by utilizing the basically renewable resources for the energy resource production, and by that way net CO2 into the atmosphere that can be reduced. So ultimately it is reducing the climatic change, helping the mitigation of a climatic change. So this is the 8th principle of the green chemistry, which talks about the reduced derivatization. You know, as an organic chemist, derivatives, we convert one form to the another derivative, and derivatization one has to reduce. So we can say fewer the steps involved, the fewer hazard material that is going to generate, and less risk is associated with the employee in the industry. So one has to reduce the steps involved. Earlier we have seen one example. This is another example, simple. This is a benzaldehyde prepared in a 2 steps. It is an old process. This is the new process which can be developed within a 1 step. It can be developed. So we can say it is a, one can reduce the derivatives. Again, the profane, which is generated in a 6 steps by Boost company, generated in a 3 steps, which is having a more atom economy, and waste generation it is less. So derivatization it is less by the company process that is called it as a BHC company. Use of a catalyst, we know again the chemist, the catalyst is used catalyzed process compared to the non-catalyzed process. Catalyzed process, it is an energy efficient process. Compared to non-catalyzed process, energy utilization is requirement is less by use of a catalyst. So green chemistry promotes the use of a catalyst in a industrial process. This is one of the photochemical process. Today photochemical, basically use of a solar light. We know the natural photosynthesis process, the plant absorbing CO2, absorbing water from the soil, absorbing CO2 from the atmosphere, and converting the CO2 and water into the food product, maybe the fruits or grains, and it gives again the oxygen, which is essential for the living things. So this is a photosynthesis process. Today, scientists are using the term called it as a artificial tree for a semiconductor. Scientists are using the term artificial tree for a semiconductor. Today, the semiconductor, a lot of semiconductors that has been developed, semiconductor having some band gap, they are having absorbing the solar radiation. There is a generation of the electron hole in the process of photocatalysis, and that electron hole that can be utilized for pollutant degradation or CO2 reduction, maybe hydrogen splitting to water and oxygen, maybe for ammonia generation. There are different applications. So nowadays the basically scientists are using this generating semiconductor for photocatalytic application, which is very similar to the natural process, photosynthesis process. So this is semiconductor, it is called it as the artificial photosynthesis, photocatalytic process. It is called it as the artificial photosynthesis process. I have not put some slide how this photocatalytic process is utilized for the hydrogen generation or CO2 reduction to different useful chemical hydrogen formation, maybe the degradation of the different pollutant. I have not put the slide, but this is used for the various application. So this is the benefit of the basically use of a catalyst. Reduction in activation energy, make the reaction faster. It is an energy efficient process. It reduces number of steps involved, hence the amount of solvent requirement is less. So catalyst develop the economic strength to the industry. Use of a catalyst, it develop the economic strength to the industry. So this is a 10th principle of a green chemistry, which talks about the design for a degradation. The chemicals, whatever it is used, they persist in an environment for longer duration. Green chemistry says that whatever the product form, it should degrade once the useful purpose is over. What is happening, many product, the DDT, it is one of the product, or many the pesticide, many preservatives, or the dyes, some what you call the antibiotic, they sustain in a environment for longer duration. They bioaccumulate, it come into the food chain, come into the water, come into the soil, then into the crop and into the food. We are consuming the food and ultimately it is coming into the human body. So it is a toxicity, it is increasing. So this is one of the example, basically how DDT it is bioaccumulating. There is a very small percentage of DDT it is found in the water, but this DDT found in a zooplankton, it is a 0.24%, 0.04%. There is an increase in the concentration of DDT in zooplankton. Then these fishes are eating this insect, and the amount of DDT found in the fishes is 0.5 ppm. There is increase in the DDT percentage ppm concentration 2 ppm in large fishes, and again these fishes are eaten by the fish eating birds, the eagles or the fish eating bird, different fish eating bird, and the concentration it is found it is 25 ppm in fish eating birds. And because of this high percentage of DDT, their population it is declining. It was initiated, this DDT it was invented in 1939 and it was prohibited in 1970. The inventor, they get Nobel Prize in 1948, but it has to be banned. And nowadays it is no more used, the DDT, in an advanced country. In some of the countries still it is used. This DDT basically declining the population of the birds because of the more concentration it is found in their body. So it has got a bad effect, persistent organic pollutant, bad effect on the animal as well as on the human being. And in order to protect from the persistent organic pollutant, there is a convention called it as the Stockholm Protocol. That Stockholm Protocol come into force in 2004, and the outcome of this protocol, it is eliminate the production and use of the 12 worst persistent organic pollutant. They identify the additional persistent organic pollutant. They find alternative to this persistent organic pollutant by the separate chemical. They ban this 12 worst persistent organic pollutant. So this is DDT is one of these pollutant. There are some other chemical which is heavily used in as a fire retardant in electronic devices, different electronic devices. This is a polychlorinated bisphenol, which is a what's called fire retardant, which is heavily used. These are some of the pesticides, the preservatives heavily used. So by this Stockholm Protocol, it has banned. The 12th principle, it is a real-time analysis. Basically, one has to analyze the process with respect to the time so that the toxicity associated with the process that can be reduced. Then the accident prevention, if we minimize the amount of the chemical used, select the substance in such a fashion which is non-hazard to the process, non-toxic to the process. By that way, the chemicals that can be the accident that can be prevented. This is one of the example. The tragedy of Bhopal occurred in 1984, and there is an emission of 42 ton of methyl isocyanide. There is a lot of death. Thousands of the people dies. Many lakhs of the people, they have a permanent injury. So this is this process that can be modified. This is an existing process. I have not put again a slide here, but this process that can be modified, and by innovation, it has a modified process. Nowadays, no more. This is a clear process is used, but same MIC is synthesized, but same this what you call the pesticide is synthesized, but the different process, and which is a non-toxic process. So innovation is essential. Innovation is performed. So green chemistry talks about the innovation, one of the definition that we discuss, the innovation. So this is again another accident, Chernobyl nuclear power plant disaster. There is an emission of lot of radioactive material. There is again disaster, which is called it as a CVSO, Italian dioxin disaster. A lot of the poultry, there is a damage of the poultry. We discuss about the basically smoke disaster, Los Angeles smoke disaster, London smoke disaster. This is the picture of Los Angeles disaster and the London smoke disaster. See the people, they are wearing the mask, the different kind of a mask in order to protect themselves from the pollutant, different chemicals. You know, the air quality index, it is very bad in Delhi, in some of the countries, some of the cities, metro cities, it is very bad. It is always severe. In Delhi, it is always severe in the winter. It is 401 to 500. And here mostly they find the particulate matter, carbon monoxide emission, and the ozone generation. And based on that, there is a calculation of air quality index. And air quality index, it is very severe in winter in most of the metros. So we have a basically different accident. There is a pollution. So basically, you know, this is one of the picture. This is the present generation. The people, a father, he is offering some wealth to the son who is unable to breathe naturally. And this wealth is not going to help. So basically the environment, good environment is essential for the survival. That is the important. The wealth is not important for his son. So basically, who are the creator of the problem? You know, and who will solve the problem? Basically, we are a part of the problem. Therefore, we must be a part of the solution. So we are all occupant on the earth, and the government agencies, civilians or NGO, one has to come together and one has to participate in the process of the development. So this is one of the quotation of a Dalai Lama, who is a spiritual leader of the Tibet. He says, we are the generation with the awareness of a great danger. We are the one with the responsibility and the ability to take a step of concrete action before it too late. It is a time to take a action in order to protect the environment and make the chemicals safer, make the chemical process safer. So this is, we know, the constitution of our country. Constitution, it has given the right as well as we have a duties. We know the fundamental right of practicing the religion, equality, pollution-free environment, again, and we know everybody, we are aware about the right. And it is attending more attention toward the right. But what are the fundamental duties? Let's talk about the fundamental duties. There are 11 fundamental duties laid in the Constitution, Article 51A, and Clause G and H talks about the protection of the environment and the natural environment and develop the scientific temperament. Why to protect the environment? Basically, it is basically the environment, it is to be protected. It maintained basically the life supporting system. Environment support the life. It gives the oxygen. Again, without environment, if environment is bad, there will be a question on the survival of a life on the earth. So one has to protect the environment. This is one of the duty of our Indian citizen. Other duty to develop the scientific temperament, humanism, spirit of equality, and reform. Why to develop the basically scientific temperament? You know, there are the people who are not promoting the scientific temperament. Basically, it helps to develop the critical and rational thinking. The people become more open-minded. It will create a progressive society and keep away from irrational practice and misconception. So there are many things happening. One has to unscientific thing, and we have to oppose the unscientific thing, and one has to develop the scientific temperament. And this is one of the duty, Indian citizen duty of ours. Then next come the sustainable development. There are 17 sustainable development goal. What is the development? We have a lot of development. We have industrialization. We have a lot of roadways, highways, bridges, the industries. But at the same time, there is an emission. For economic growth, we have a economy. We have a more high $4 trillion economy. But the pollution is very high. So the one concept that has come, that is the sustainable development. That development meets the need of a present generation, meet the need of today's generation, present generation, without destroying the planet for the future. It balances the economic growth. Today, we focus more on the economic growth, balance of the economic growth. We don't much focus on the basically what you call the environment. So protection of environment is very much essential in order for a future generation. So sustainable development, it is basically improvement of a lifestyle and well-being, and preserving the natural environment and ecosystem, balancing the economical growth with social equality and environmental protection for the present and the future generation. There are these 17 sustainable development goals. Will not have a time. I think time is over. Just within 2-3 minutes, I will go through some of the slides of a sustainable development. So this is basically this is one of the scientific approach for a climate mitigation, heavy consumption. Basically, okay, I will go through this. So this is a statement of a Mahatma Gandhi, our father of nation. He says, in an ecosystem of finite resources, there has to be a finite consumption. The earth has enough resources for everyone need, but not enough for everyone greed. So resources are fixed. We have ores or minerals, water, it is a fixed. So in a precise way, one has to use it. So it is enough for everybody needs, but it is not enough for everybody's greed. So finite consumption, the resources are finite. So in a finite fashion, one has to use the resources. Where one has to see the consumption in a sustainable fashion. The fashion industry today, a lot of the cheaper goods are coming out and people are purchasing, people having a money, but they are utilizing the energy, they are utilizing the resources, and they are creating the basically waste, dumping the waste. So it is contributing to the global warming, and again, more CO2 it is going to emit into the atmosphere. So one has to use a clean water. That is this is a sustainable development goal, sustainable development goal 6. Clean water, it is to be provided to everyone. Then one has to, there should not be a hunger in the country. That is the sustainable development 13 and 12. 2. There has to be a use of basically public transport to reduce the carbon emission and reduce the climatic change. This is an example where 17 vehicle people are independently driving, and 17 people that can be accommodated in a 71 bus. So consumption resources is very less, emissions is less by a one bus compared to the 70 private vehicles the people they use. So emissions is high, consumption of resources is high, maintenance is high. One has to plant a tree so that which will help for a development. The plantation, today plantation performed by the politicians, and this plantation, the survival rate of this plant is hardly 7%. So once they plant a tree, they don't bother about it. And, the survival rate of this plantation is hardly 7%, 8%. So though the people lakhs of the trees are planting, but the survival of the plant is very less. So this is a one quotation that is a luxury and lies have a huge maintenance cost, but true and simplicity are a self-maintained without any cost. So simplicity, it is important. I end my talk with this quotation. Our environment, the world in which we live and work, is a mirror of our attitude and expectation. So one has to change our expectation. One has to change our attitude towards the use of the different resources. And to some extent, the process development, product development, the green chemistry aspect, that is going to help for the sustainable development. So thank you all for your kind attention. And thank you organizers, Dr. Kodape Madam, Professor Kodape Madam, and all participant for invitation. So thank you. I'll be happy to answer the queries.
Thank you, sir. Thank you so much. Participants, the forum is open for discussion, and or if you have any questions or the queries, you can directly ask to Professor Umbre, sir. Please, anyone. Having any queries or the questions?
Hello. Yes. Any queries? Any suggestion? You can give me any suggestion. Okay. If you don't have a query.
Good afternoon, sir. That was a wonderful presentation. Organic solvents in the chemical reactions.
Okay.
Sir, minimization of organic solvent in the reactions. Does we have any other alternative?
Your voice is breaking. It is not clear. Can you talk?
Dr. Arif, sir, your voice is not very much proper, sir.
Sir,
can you talk now?
Okay, sir. Sir, I was asking about what should we do to minimize the use of organic solvents in the chemical reactions?
Solvent.
Does we have any other solvents?
Basically, the organic solvent, all organic, most of the organic solvent, it is a toxic, the benzene, toluene, xylene, DMSO, DMF. But toxicity, it is high in an industry. Toxicity is less in laboratory. We use a small quantity. But we again talk about, the supercritical CO2, supercritical water. Right, supercritical water, supercritical CO2. I not discuss much about this concept, but the property of a supercritical water, supercritical CO2, it varies with the critical temperature and pressure. Right, if you vary the temperature above critical pressure and temperature, the property, it is going to become different. Okay, I will come to this slide. You will have a clear little bit idea about it. The CO2, okay, this is the slide, okay. So supercritical CO2, right? This is a temperature 31.1 degrees centigrade and critical pressure 72.9. Above this, maybe 32 degrees centigrade, maybe slightly higher pressure, maybe 73 bar atmospheric pressure. The property of that supercritical CO2, it will be different. Right, hydrophobicity, hydrophilicity, it will be different. Maybe the dielectric property, even the water. This is an example of a CO2. If you take an example of a water, right, above critical temperature, pressure, the water, it will be having a different property. The dielectric property of a liquid water, ice water, right, vapor water, supercritical water, it is different. Properties are different, right? So one can select a condition. Under that, we can use a supercritical water, supercritical CO2. Again, I talk about the green solvent, right? The what do you call the green solvent? What do you call ionic solvent, right? Ionic solvent. One can select a ionic solvent which is a less toxic in nature, but no doubt it is a costly one. Right, ionic solvent, they are costly, but they are green. They are less volatile, highly non-volatile in nature. And again, the property, you have a varieties of a ionic liquid. one can vary the property of ionyl liquid by varying the cation and anion in it, right? Organic cation, organic anion. So that can be selected instead of the conventional organic solvent. One can select a ethyl lactate. It is a biodegradable, and so that the toxicity it will be less. So these are the basically different solvent one can select, right? So in order to make the safer reaction, a non-toxic reaction, or a sustainable reaction, sustainable process or a product, right?
Thank you, sir.
Any further question?
Sir, you have discussed that desulfurization to reduce sulfur content. Is
Yes.
thermal power stations in India are using this desulfurization process or not?
I can't say whether they are using or not. This is a scientific discussion, right? How
Yeah.
it can be utilized, right? How to
Yes, sir.
utilize the sulfur emission into the atmosphere. This is an academic discussion. This is a process, right? The scientists, they can develop the process. Who will utilize it? Industry is supposed to utilize it. Maybe cost involvement, right? It involve the cost. May not be economical process, but it can make economical one also, right? So since the cost is high for some of the process, so industry don't use it. That is the thing, right? So sulfur, if it is extracted in the beginning of the process, so that the sulfur free coal, if it is used for thermal power plant for power generation, it will be a sustainable process, right? So whether they are not using, okay, they may having their own problems, maybe some different issues with them, why they are not using it, right? I think some industries, some plant are using, government are again imposing some of the norms on some industry and thermal power plant. So which process they are using? There are different process. This is the one desulfurization process. Other one is again simply addition of calcium carbonate, right? Spray of a calcium carbonate. Calcium carbonate that can be sprayed so that sulfur can interact with the calcium calcium oxide, and it will form a calcium sulfate. Calcium sulfate, it is a solid, right? It can be extracted. Sulfur can be extracted from the emission. So this is another process. So there are various processes. One process I discussed, that is the desulfurization, and using, not using, okay, it is left to the industry, and government has to see it. As an academician, these are the process we are discussing. Is it right?
Thank you, sir.
Hello. Yeah. Again, any question?
Yes, anyone has any questions? If there are no questions, then we can conclude. Sir, I think there are no more questions. So if you could permit, shall we conclude, sir?
Okay.
Yeah, so now may I request Dr. N. Dakshinamurthy sir to please propose vote of thanks for current session. Dr. Dakshinamurthy, please.
Yes, sir. Very good afternoon, one and all present here. I am Dr. Nedumaran, Assistant Professor of Chemistry, Presidency College, Chennai. On behalf of UGC MMTTC, San Gadge Baba, Amravati University Director, Course Coordinator, and the fellow participants, I extend my heartfelt gratitude to this session's resource person, Dr. Suresh Humre, Professor, Department of Chemistry, BNIT Nagpur, for his inspiring session on green chemistry and sustainable development. Sir, your excellent presentation was truly enlightening, and it provided us with a deep insight into eco-friendly chemical processes and their role in achieving sustainable development goals. Sir, from your presentation,
Sir, you are muted, sir. Please unmute yourself. You are muted.
Oh, yes. Am I audible, sir?
Yeah, sir. You are audible.
Yeah.
Very, Very good afternoon, one and all present over here. I am Dr. Nedumaran, Assistant Professor of Chemistry, Presidency College, Chennai. On behalf of UGC MMTTC, San Gadge Baba Amravati University Director, Course Coordinator, and the following participants. I extend my heartfelt gratitude to this session's resource person, Dr. Suresh Umre, Professor, Department of Chemistry, VNIT Nagpur, for his inspiring session on green chemistry and sustainable development. Sir, your excellent presentation was truly enlightening and it providing us with deep insight into eco-friendly chemical processes and their role in achieving sustainable development goals. Sir, from your presentation, we understood that the green chemistry and sustainable development are not simply words. These terms are the solution for pollution and which are ensuring the existence of life on Earth. You have thrown a light on evolution of green chemistry concept, the 12 principles of green chemistry, carbon credit, artificial tree, biomagnification, etc. The takeaway message from this session is we should protect the environment and hand it over to the next generation. We sincerely appreciate your time and contribution to make this session very effective and highly informative. Thank you, sir. It is my pleasure to thank the course coordinator, Dr. Manisha ma'am, Dr. Ankit sir, and the technical team for their tireless effort to conduct the course effectively and successfully. I thank the participants for making this session interactive and effective. Finally, I thank the Amravati University for conducting refresher course in chemistry effectively. Thank you, sir. Thank you very much for all. Thank you, sir.
Thank you. Okay, thank you.
Thank you, sir.
Okay, right. So,
thank you, sir.
I will leave the
so
meeting.
much. With the kind consent of Professor Umre, sir, I would like to declare that this session will be over here. We will stop now here and meet 2:30. Thank you so much, sir, and thank you, everyone.
Thank you.
Hello, Dr. Manisha. Shall we start?
Can I introduce, ma'am?
Yeah, please, sure. Go ahead.
Thank you, ma'am. It is my privilege to introduce our esteemed guest speaker, Dr. Preeti Khelkar, ma'am, Associate Professor in the Department of Chemistry at Guru Nanak Khalsa College of Arts, Science and Commerce, Mumbai. Dr. Khelkar, madam, holds an MSc PhD and has completed her postdoctorate research at IIT Bombay. She has 16 years of undergraduate teaching experience, 14 years of postgraduate teaching experience, and 25 years of research experience. Her research specialization includes organic synthesis, development of new synthetic methods, and the synthetic synthesis of unnatural amino acid derivatives. She has published 14 research papers, completed 3 minor and 1 major research project, and has also filed a patent. She is the recipient of the prestigious DST Fast Track Young Scientist Research Grant and the BASF Travel Stipend for Young Indian Scientists. We are privileged to have her as the resource person for the UGC sponsored refresher course in chemistry 29th June to 11 July 2026 being conducted in online mode. Today she will deliver an insightful session on the research paper writing in chemistry from experiment to publication. Please, ma'am.
Good afternoon, everyone.
Good afternoon, ma'am.
Thank you for your kind introduction. So at the outset, I would like to express my sincere gratitude to the organizing team, especially Dr. Manisha Kodakwe, the course coordinator, for giving me this opportunity to interact with all of you, dear participants. It is pleasure to be among fellow chemistry teachers. As teachers and researchers, we all spend a significant amount of time in the laboratory, guiding students, conducting experiments, and generating data. However, one of the biggest challenges we often face is converting that research into a well-written scientific paper, and today's session is designed to make that process simpler and more systematic. We will discuss the complete journey of a research paper from planning and organizing the manuscript to writing each section and selecting right journal, responding to reviewers' comments, and finally getting the paper published. I hope that by the end of this session, you will have a practical roadmap that make research paper writing easier and more enjoyable. So I will share my presentation right now. The only thing is, I don't know if I'm audible clearly or not. Could you please let me know if I'm audible properly?
Yes, ma'am. You are very much audible.
Yes, ma'am. Yeah. So thank you. What is happening is here in Mumbai, we have really gusty winds and it's raining also of late now. Like morning, it was very clear weather, but now it's again raining. So internet stability can be a little problem. I hope I'm clearly audible. And now my screen is visible. There is a presentation on the screen, right?
Yes, ma'am. Yes, madam.
Yeah. So my camera will be on and off. Maybe it depends on the load of the meeting. I just would try to put it on. I don't think it is taking a load. I don't know. Could you see me?
Yeah. Yes, ma'am.
Yeah. So thank you. So the title of the lecture is Research Paper Writing in Chemistry from Experiment to Publication. So I have another screen wherein I have kept my PPT open, and that is how I will be operating this. Okay. So why do you publish the research first of all? Because research is only valuable if you let other people in the same field know what you are actually doing it, what are your new findings in that particular field. That is how you will share your knowledge with the researchers around the world, right? So publishing helps us to communicate new knowledge, ensure our work is validated through peer review, and allows other researchers to build upon our findings, right? So that publishing is an important thing, and that ultimately creates an impact on the society through education, industry, and innovation. Now, before writing a research paper, ask one important question: is my work publishable? See, good research should offer something new, use scientifically sound and reproducible methods, and it should address an important problem. And it should be supported by a reliable data. It should also be written in a clear and logical manner while following all ethical and publication guidelines, right? So this is how you should look at your work before you start writing a paper. Now, this slide perfectly captures the biggest challenge every researcher faces. Conducting experiments and generating ideas is one part of research, but converting those ideas into a clear, well-written paper is often much more difficult. So good research alone is not enough. It must be communicated effectively. Okay. Today, publications are one of the best measures of research impact. Publishing in good journal shows your scientific contribution, increases the visibility of your work, and it creates opportunities for collaboration, funding, and of course, career growth. And see, if you don't publish it, you have not done it. Nobody knows about it. And the credit goes to the guy who first publishes it. Okay, so it is very important to publish within time limits. Like, I have done some work 20 years back and now I want to publish it. Until and unless it is something groundbreaking, and until and unless nobody had been exploring in that particular field, you will be able to publish after 20 years. Otherwise, somebody would do it, in the due course of time. Now, see, this is the depiction which highlights the importance of publishing all research findings, including negative results. If unsuccessful experiments are not shared, other researchers may unknowingly repeat the same work, right? So other researcher in the some other remote part of the globe would be doing the same kind of work which you have done it, and you have understood that it doesn't work this way, but unknowingly that person is repeating same work, wasting time, money, and resources. Publishing negative results helps the scientific community learn from failures and take the research forward more efficiently. So it is very important to even publish negative reports. So these are the types of scientific articles you can publish. So original research findings, you can just publish your new results, new findings as original research articles, right? Then review articles summarize existing research. Short communications are meant for communicating important results quickly, that okay, I have found really something new, I will explore many more things in this field later on, but it is going to take time, but this finding is very important. You write a short communication. Perspectives share the expert opinions, and technical notes describe new methods or techniques. Suppose you have found some new method to determine adulteration in milk. you communicate as that particular piece of work as a technical note, right? There are various types of scientific articles, and good scientific writing follows the 7 C's. Okay, it should be clear, correct, complete, concise, and conform to the journal guidelines, and be consistent in style and terminology, and above all, always common sense is very important while writing. These simple principles make your paper easier to read and understand. Now, how is the structure of the scientific paper? There is no single way to organize your research paper. Over the years, different paper writing models have been developed to help authors present their work in logical and effective manner. And in the next few slides, we will look at 3 commonly used models for paper writing, right? So these are the important sections in the scientific papers, and so let us have a look at the 3 commonly used models for research paper writing. No single model fits every research paper, and different models help organize ideas logically. They improve the clarity and flow of the manuscript. And common models are hourglass model, emerald model, and king model. Now, each model serves a different purpose, right? Go to the next slide, and this slide shows you an hourglass model, right? It is called hourglass model because its shape is wide at the top, narrow in the middle, and wide again at the bottom. Wide again at the bottom, right? So see how beautifully it shows how the scientific paper should be organized, right? We begin with the broad background, narrow down to our question and findings, and then expand again to discuss the impact, limitations, and future directions of the study, right? That is how it works, right? And then is the emerald model, which is most widely used format for writing original research papers. It divides the paper into 4 sections: introduction, methods, then results, and discussion. Okay, introduction and literature review, they are together. That is what the introduction is. Why is this research important, and how was the research done in this particular area? So emerald model is commonly used. Why was the study done? How it was done? What was found? And what do results mean? What is the significance of the results? This format makes the paper clear, logical, and easy to follow, right? Then comes the King model. King model provides a complete picture of the research paper. It shows how all the sections from title and abstract to references fit together in logical order. It is specially used for students and first-time researchers because it helps them to plan the manuscript before they start writing it. Okay, so it is the widely used model for paper writing. Now, so this is the first part of the paper. The title is the first thing readers notice. A good title should be clear. Good title should be, it should be clear and specific, and accurately describe the research in as few words as possible. It also helps search engines and indexing databases find your paper, making it easier for other researchers to discover your work. So it is very important part. A good title starts with the main subject of the research and clearly reflects the focus of the study. It should be accurate, specific, as I said, and easy to understand. Avoid unnecessary abbreviations and make the title enough attractive to encourage readers to explore the paper further. Okay, so title should be such that readers should feel, oh, this paper is something interesting. Now, there are various types of titles, you have a descriptive title, you have a declarative title, interrogative title, and compound title. So, descriptive title is a title which states what the research is about without revealing the main findings. You're not talking about results, but you're telling what is this research all about. In declarative title, there is it clearly states that the main conclusion or key finding of the study, what is the key finding that is clearly shown, right? In interrogative title, the research is put in the form of question to attract readers' interest. And in compound title, it combines the research topic with the main finding or significance using colon. Okay, it is going to use colon. So these are the examples. Okay, when you have a descriptive title, it says green synthesis of silver nanoparticles using plant extracts. Okay, what you have done is green synthesis you have done of silver nanoparticles, and how you have done it using plant extracts. Okay, so you are telling what is this research all about, what is this paper all about. Now, declarative title is plant mediated green synthesis produces highly stable silver nanoparticles. So whatever your finding is, that also you are trying to tell it that, okay, highly stable silver nanoparticles are produced using plant mediated green synthesis, right? And now interrogative title is something like, can plant extracts replace chemical reducing agents in silver nanoparticles synthesis? So you are posing a question, okay, trying to make your work interesting. And compound title for the same work can be green synthesis of silver nanoparticles. Can plant extracts replace conventional chemical methods? So that is a compound title. Okay, so 4 types of titles: descriptive title, declarative, interrogative, and compound title. Okay, for your title of the research paper. So again, descriptive titles are best for broad discoverability. Declarative titles, they highlight the key findings, what is your paper about, and interrogative titles, they try to engage readers but are used less frequently in chemistry journals. However, compound titles are very common in high impact journals because they provide both context and the key message in concise format. You are trying to tell what is found and what is done, okay, together. So yeah, this is how abstract is important. Abstract should convey your paper in brief. Everything you are going to convey through abstract, right? And then let's go to the slide. Yeah, so an abstract comprises a 1-paragraph summary of whole paper. Abstract is just giving a trailer of your whole story. Everything of relevance to potential readers should be there in the abstract, and everything else shouldn't be there. Okay. There are two types of abstracts. An informative abstract, it depicts everything relevant from the paper, research objectives, methods, results obtained, everything. And such abstracts may serve as highly aggregated substitute for the full paper. Then there is an indicative type of abstract which describes the content of the paper and may thus just serve as an outline of the paper. Okay, this kind of abstract cannot serve as a substitute for the full text, right? I hope my PPT, this slide is about checklist for abstract, isn't it?
Yes, ma'am.
Yes,
ma'am.
because
Yes, ma'am.
I was just concerned if
Yes,
it is moving according to what I am talking about, and yeah. Okay. So, checklist for abstract, how do you check whether your abstract is proper or not is your abstract should start with some statement which describes why do you care about the problem, why you have undertaken this particular research, that you have to make it very clear. Why do you care about this problem? Then what problem? What is the problem exactly? Precisely you tell what is the problem. And then you say, okay, what was done to solve this problem? And then, okay, what did you find it? What is your answer to the problem? And what is the significance and implications to the significance and implications of the results, whatever you found it, right? So that is the checklist for the abstract. You should see that all these things are addressed in your abstract. So this is one of the papers which I have selected to show you the abstract. For that matter, even you see the graphical abstract that is also made beautifully in this paper, right? This paper is published in JOC, Journal of Organic Chemistry, published by ACS, American Chemical Society, and they have described everything so beautifully. So this abstract first statement is alpha and beta substitution of dihydrocinamates has been shown to increase the biological activity of various drug candidates. Okay, so it talks about why do you care about these particular dihydrocinamates having alpha and beta substitution. Okay, how they are important. Then they come to the problem. Recently, we identified that enantio and distereopure alpha methyl beta cyclopropyl dihydrocinamates to be important pharmacophores in one of our drug discovery programs. Okay, so that is the importance now, and endeavored to devise an asymmetric hydrogenation strategy to improve the access to this valuable framework. Means synthesis using some simpler method is required. That is the problem. Okay, simple method is required for the synthesis of these type of compounds. Okay, and then they talk about the solution. They say we used high throughput experimentation to define stereo convergent Suzuki-Miyaura cross-coupling conditions, blah, blah, blah. So this is what we have done it. And result also they have blended, saying affording the desired products in excellent enantio and distereo selectivities. Means using this methodology, we are getting the desired products which are important. They have already told about the importance, and then now they are saying that okay, this method delivers desired products in excellent enantio and distereo selectivities.
And then they talk about the significance of the result, that they say these conditions were executed on multigram to kilogram scale. See the utility of the methodology to provide 3 key enantiopure compounds, with high selectivity. So you are getting a compound in an enantiopure state, right? Kilogram scale they have gone to, and that is the significance of their research. So in one single, abstract, they have shown everything, why this research was done, what was the actual problem, then solution to the problem, what is the result, what are implications, everything they have talked about it. And now this another paper, again a JOC paper, wherein a graphical abstract is also very nicely done, and this abstract is very concise abstract, right? So see, motivation or say background is what they say, the need of an efficient oxidation method is implied rather than explicitly stated. See, what they have done is an efficient and rapid oxidation of various aliphatic amines to oximes using metachloroperbenzoic acid as an oxidant in ethyl acetate is described. Okay, and then they tell about problem. They have said that method used is MCPBA is used as an oxidant in ethyl acetate, and they talk about result also. What they say is high conversion, quantitative yield with more than 90% oxime selectivity is achieved at room temperature under catalyst free conditions. Okay, and then conclusion also, they talk about the significance of the results also, mild reaction conditions along with an easy workup procedure, lower byproduct formation, high selectivity for oximes in good yield and purity. So small, concise, in fact concise, I should say, abstract, but conveys the gist of the paper really nicely. So we talked about what should be there in the abstract, what shouldn't be there in the abstract is information and conclusions not stated in the paper. Okay, you're performing some research, you are presenting some part of it in the paper. So what is not there in the paper, don't try to put it in the abstract. References to other literature are not required in the abstract. You should not put citations in the abstract. The exact title phrase, don't use it as such. Then illustrative elements such as figures and tables are not a part of abstract. Okay, exact phrases which are going to appear later in the introduction or paper anywhere, don't put these things in the abstract. Fine. Then after abstract, an important part is keywords. Okay, keywords are important because they describe the main subject of your research. They include the key concepts, techniques, or materials used in the study. Well-chosen keywords help indexing databases and search engines to find your research paper, making it easier for the other researchers to discover your work. So keywords, while writing keywords, you should be very critical that what you are trying to put in as keywords. Fine. Then is the introduction. See, the introduction takes the reader from the broad topic to your niche area, right? Your particular area of research. So first you need to explain why this topic is so important, and then briefly describe what is already done. Next, you will identify the research gap or the problem that still needs to be solved. So you will talk everything. Okay, this thing is there, that thing is there. Create a story and then tell, oh, everything is there, but this particular thing, nobody is addressed it. Okay, so finally you will tell, oh, this problem needs to be addressed. And finally state that aim of your study and explain how your work is going to address that particular research gap, right? The introduction should guide the field and should allow the reader to understand the rest of the paper without referring to a previous publications on the topic. When they read your introduction, at no point of time they should feel that, oh, I have to go back to this paper, cross-reference, and then I need to look into it, oh, what is done. No, you should be able to tell the story clearly. So the next is the body of the paper. Now, body is the main part of the research paper. It explains how research was conducted, material methods, or say experimental section. Okay, in case of chemistry journals, most of the times it is experimental section, and it comes after results and discussion. Okay, but there are still journals in which materials and methods is there, and it is before results and discussion. Okay, so results and discussion is again a very important part of the paper. It presents what was found and what is the justification of your results, significance of your results, and then you organize this information in logical sequence, and there can be sections or subsections depending on the see, each journal has different format, and based on the format which they have given it to you, that only you need to follow it. So results discussion, I would say this is the most important part and experimental section, of course, wherein you are going to show people why this work is so important, what you have done, and what is the significance of your work. So you will present the key findings clearly in this particular section using say tables, figures, graphs, spectra. Interpret the results by explaining what the findings mean. Okay, discuss the importance of your findings, mention any limitations, and finally explain how your work contributes to the field and what future research can be done in this particular area, right? So the results and discussion section should begin by presenting the most important experimental observation. Okay, uh, everything, whatever data you have generated during your research, you should summarize using schemes, tables, say graphs, or you can put spectras, and then images, and make the text lengthy. Try to use these tools to depict the, right? Now, for example, you are writing about acetylation of 2-naphthol and you're getting 2-naphthyl acetate as a product. So you write everything in the results and discussion. When you say that acetylation of 2-naphthol was done, it produced 2-naphthyl acetate, you got white crystalline needles in 88% yield, you have shown this reaction in scheme 1, the FTIR spectrum exhibited strong ester carbonyl absorption at 1738 centimeter inverse. So like that compact way, you will try to give maximum information. And immediately after presenting the data, explain what the observation means scientifically. Okay. Discuss whether these findings support the research objective and relate that to the established chemical principles. Okay. For example, whatever we had been talking about acetylation of 2-naphthol, the disappearance of phenolic OH stretching band and appearance of ester carbonyl peak confirms the successful acetylation of 2-naphthol. That is how you can discuss it. That how did you say that, okay, my product is formed. I had been monitoring it using IR. Okay, that phenolic OH peak is not there. Now new peak is there. Okay, you have spoken already about the yield. The high yield indicates that the reaction proceeded efficiently under the optimized reaction conditions. If you are talking about some new catalyst, you can say that, okay, we are getting better yields than the literature or whatever it is reported in the literature methods. Now, place your findings in the context of previously published work, as just like as I said. Okay, compare yields, reaction times, selectivity, spectral data, catalytic performance, whatever your work is related to. Try to put the comparison with the existing methods. Discuss the possible reasons for similarities or differences and explain how your work advances the current knowledge. What is your contribution? Why your method is important? Okay. So you can say this present method developed by us afforded 88% yield compared to 80% reported in the earlier studies. The improvement is likely. Why this improvement? Of course you will justify that also. That is why you are researcher. You are going to provide justification for that also. How your method is the improved method and why this improvement is there. The improvement is likely due to the use of freshly distilled acetic anhydride and optimized reaction temperature, okay, resulting in the fewer side reactions. So if people did not mention that acetic anhydride was distilled, you are mentioning that, okay, we purified acetic anhydride, so our yield is better. Maybe we are performing our reaction at say 25 degrees, so our yield is better. Okay, that whole discussion will be here, okay, in the results and discussion. Then whatever your conclusion is, support your conclusions with chemical reasoning. Okay, because you are a researcher, you cannot just found this. I have a method. I have to then give some insight in the mechanism also. Okay, what is happening during the reaction? Okay, so is my presentation there on the screen?
No, ma'am.
Okay, I'll share it
No,
again.
ma'am.
I'll share it again.
Hello, Preeti madam. Hello.
Just a minute. We are trying to do this. Maybe this bandwidth is not enough. I'm working on it. Just give me a minute. Okay. Could you see screen?
Yes, ma'am. Visible.
Yes, yes. Now it's visible, ma'am.
Okay, thanks. Yeah. Okay. So we are at results and discussion part, and wherein we had been talking about that results in discussion, you should be explaining the chemistry behind your research, right? That is what we had been discussing it, that you should support whatever conclusions you have it with chemical reasoning, right? You explain reaction mechanisms or whatever spectroscopic data that you are presenting it, you should provide discussion related to that data, right? So, for example, as we had been talking about acetylation reaction of 2-naphthol, example I have covered here is that the reaction proceeds through a nucleophilic acyl substitution mechanism in which the phenoxide ion attacks the carbonyl carbon of acetic anhydride, right? So the slight reduction in yield at higher temperature may be due to hydrolysis of acetic anhydride or competing side reactions, right? So once you have said you have said that you are getting 88% yield as compared to literature 80% yield, and then you have said that okay, the reaction was performed at 25 degrees with distilled acetic anhydride. Now you are explaining why that distillation and temperature at 25 is helping you getting 88% yield. Now you are explaining that also, saying that okay, at higher temperatures maybe hydrolysis of acetic anhydride takes place, so we are controlling the temperature. We have distilled the acetic anhydride and then we are using it pure one, and we are controlling hydrolysis part also. Okay. And then you are talking about the mechanistic part also. That is how results and discussion is done. Work at say 0 degrees, you have screened the reaction conditions, so say clearly that 0 degrees reaction doesn't work, at 15-degree reaction didn't work, 25 degrees yes, you get optimized yield, if you go to higher temperature again yield reduces. Everything you discuss it, okay, make a table, give temperatures, mention your yields against the temperatures, right? State the significance, scientific significance of the findings, as I said, and suggest the possible future work also.
Yeah.
Very, very sorry as it is raining heavily. Maybe internet connection is little unstable. Can't help it. But yes, I'll go ahead. I think I have shared my screen. You will be able to see it in a while. Yeah. It's more than rain, it's wind. Okay, that is the problem. Okay. So, after results and discussion, we go to the experimental section. Okay. Uh, Experimental section in some journals, materials and methods in some journals. Okay. What you have it in the experimental section is you cover everything like details of the chemicals, instruments, reaction conditions, analytical techniques used for the study. The information should be clear enough for another researcher to reproduce the experiment successfully. That it's not like I have done the experiment and I don't know whether other people would be able to do it or not. Okay, that should not be the thing. Okay, so provide a complete list of all chemicals, reagents, solvents, catalysts, standards used in the study. Mention the chemical name, supplier, manufacturer, purity of your reagent, catalog number. State whether the chemicals are used as received or you had purified before using it. Okay. Describe the preparation of stock, right? How did you prepare stock solutions, buffer solutions, reagent mixtures, everything including concentrations and storage conditions. Any hazardous or moisture sensitive chemicals should be specifically identified and reported. Okay, that okay, this is moisture sensitive, so this is the precaution we had taken it. Okay, we had used a glow box, we have used a nitrogen atmosphere while opening this bottle. Okay, say it clearly that we bubbled nitrogen gas, reaction was performed under inert atmosphere, all reagents were handled under inert atmosphere. Everything clear. So poor reporting example is shown here, that 2 naphthol and acetic anhydride were used in the reaction for the reaction. Okay, and see the example for good reporting. Okay, 2 naphthol, 99% purity, bought from Sigma Aldrich, AR grade acetic anhydride, bought from Merck. So specify these things. Ethanol was used for recrystallization. The ethanol which we have used is HPLC grade. Everything is important. Then see the example for instrumentation also. Like you need to include instrument model, manufacturer, country. Okay, if your instrument is imported or indigenous, mention it very clearly with company name. Okay, report important parameters such as wavelength, detector type. If you are reporting some NMR, say like 400 megahertz machine or 300 megahertz machine, and which solvent was used to record your proton spectrum or C13 spectrum. So whole thing should be there, right? Now see, UV visible spectrum was recorded using a spectrophotometer. No, what is the make of that your UV visible spectrophotometer? You give the complete information. Okay, range of wavelength. Okay, everything, which software was used by that particular machine. Okay, everything you should mention it. If you are outsourcing the data, you're getting data from some other place, you get the information from them also. And the other important thing is, in the acknowledgements, mention that from where you have received this data. Although you have paid for the data, then also mention it clearly from which place you have taken this data. Okay, then if you are writing a experimental procedure, of course that if you have done some reaction, you will write the experimental procedure. So that method should be in a logical, chronological and detailed manner. You should write it. Okay, include the quantities of reactants, solvent, volumes, reaction conditions, or mixing, stirring, whatever you have done it, mention it clearly. Describe the purification methods such as filtration, extraction, recrystallization, chromatographic purification if you have done, drying, everything in a crystal clear manner. Okay. See, when you talk even about column chromatography, mention the silica gel particle size, mention which solvents procured from where you have used, in what concentration, like 60% petroleum ether, 40% ethyl acetate. Okay, these things are important for reproducibility and credibility, of course, of your work. Okay, so if you have done replicates, okay, experimental replicates, mention the number, okay, how many times you have done this, and if you have performed any control experiments, that also you should mention it. Okay, if you have followed a previously published procedure, give the reference for the procedure. So this is again how poor reporting is and how good reporting should be. So when you write 2 naphthol, you have taken it, write how many grams, so how many millimoles or moles, right? Whatever. Then how many minutes you have done this reaction, for 30 minutes at 140 degrees. After cooling, reaction mixture was poured onto the ice water, okay, recrystallized from ethanol, washed with cold water, experiment was performed in triplicate, everything should be clear. Characterization techniques, again, as I uh, told, uh, all the instruments, the complete detail of its specification should be there, and then range of operation, like that also everything should be mentioned, right? For any new compound you are synthesizing it, see, the logical order is you take melting point or boiling point, you take TLC RF value, mention the solvent system, then you will take UV, you will take IR, then proton NMR, 13C NMR, and then HRMS data. If you are going to depth or any other kind of data, for uh, discussion part, then and methods section should contain enough information for other researcher
Dear participants, Preeti madam, actually she is facing lots of network issues because of the heavy rainfall. So she is trying to connect to all of us. We just need to wait for a few minutes.
Okay, ma'am.
Yes.
Okay, ma'am.
Okay.
Am I audible? Presentation is there on the screen?
Yes, ma'am.
Yes, ma'am.
Yeah,
Yes,
thank
ma'am.
you.
Yes,
I'm
you are
really
audible.
sorry.
Yes, ma'am.
Yes. So we had been talking about characterization techniques and yeah, so instrument details should be given properly in every paper and characterization techniques, whatever characterization techniques instruments and reagents you have used even. You know, reproducibility is very important parameter. See, there are papers in which they will otherwise, but when we performed it, we did not get the similar kind of results. Okay, there are papers stating these things. Okay, so while writing the experimental details, you should think included so that the experiment is reproducible, right? So you should include even information on biological or technical replicates and error and uncertainty measurements. Avoid any kind of ambiguity. Okay, so this is again an example of poor reporting and good reporting. So reaction performed in triplicate, how calibration was done, and how results are obtained. Everything should be there. The last part of your paper body actually is the conclusion, right? So you are going to summarize briefly all your findings and state whether the research objectives were achieved or not. Okay. It also highlights the importance of work, mentions any limitations, and suggests possible directions for the future research. Okay. You will avoid introducing any new results in the conclusion part, right? So, this is the conclusion part wherein you cannot just write that the study was completed successfully and the results were satisfactory. No, you have to say like how did you confirm that you bought this product, how your method is important, how it is simple, how it is reproducible, how it provides a useful approach for ester synthesis, right? So all these things you will mention in the conclusion. Then comes the acknowledgement part, wherein you will acknowledge, of course, the institute, laboratory, wherein you have used infrastructure, then funding agency along with the grant number. You will also acknowledge any technical or analytical assistance. That is what I had been talking about. That you will say that, okay, from so and so center, we obtained the data, right? And if somebody, individuals who contributed but do not qualify as authors, you don't want to include them as author, but they have contributed to your work. Suppose somebody's tried to somebody's helped you to understand the reaction mechanism. You have taken a guidance from that person. So you will acknowledge such people also. Now, references is the last part of your paper. Embedding your own work with the literature work, related literature work, is one of the essential parts of the research writing, right? You should cite all the sources referred to in the manuscript. Follow a journal reference style, citation style, whichever journal you are targeting at, paper you are targeting at, right? And ensure every in-text citation appears in the reference list. In-text mein citation is there, but reference list it is not appearing, then it is not a good thing, right? Include complete bibliographic details, right? It depends on the template of the paper also. So, it should not be like something which you have used as a reference. You have talked about that particular piece of work in your introduction part, but you are not citing it. Okay, that should not happen because that is really frustrating for other researchers working in that particular area. Do not ignore the valuable contributions in that particular field done by other researchers. Now, see, references, there are two things in references. One is in-text citations, and the another thing is, lastly, you are listing down the references. So, in-text citations, you have to follow whatever guideline is given by the journal. So there is this type also, like name and year system. This system is very convenient for authors as the citation does not have to be changed when adding or removing references from the list. Then alphabet number system, right? This type of citation is relatively convenient for readers and it does not break the flow of the words while reading a sentence with many citations. And then citation order system. This system is similar to the alphabet number system with one difference, that the reference list is not sorted alphabetically, but in the order of appearance of citation in the text. So it depends on the format of the journal. If your journal which you are targeting at is not providing any format, then probably it is not authentic journal only, because authentic journals will have their own format template. They will ask for the papers in specific template. Okay, authors have no choice than adhering to the style required by the publishers. Now, regardless of the citation style, there are two basic rules. Every cited source must be listed and every listed source must be cited. Okay, so this is the ACS style, American Chemical Society. They want author names followed by the title of the paper, then journal year in bold, then volume of the journal in italics, and then page numbers. This is Wiley style. Then RSC style, Royal Society of Chemistry. This is how they want you to write the references, listing of references. And nowadays, you have software tools that help to organize and manage research references. Okay, they allow to store articles, insert citations while writing, and automatically generate reference lists in different journal styles, right? So these reference managers, you can really learn about them and use while writing your papers. Then accessories to the text. Okay, many a times tables and graphs you can include in results and discussion part, but some supporting data will go to the supplementary data, right? So if you are enclosing any tables should be easy to read, understandable on its own, orderly and logically organized, and in agreement with the rest of the text. Captions and footnotes are must. Look at this table. See, there is a proper caption, there is a footnote. Everything is so well organized in the table. Okay. Figures, of course, captions should be put below the figure, right? Then figures should be self-explanatory. Figures should be placed as closely as possible after being referred to the text for the first time, and use the same abbreviations as used in the text and the tables, right? Graphs, you can use efficiently. You can use colors, you can use the simplest possible forms, and be consistent in font type used in your graphs. Okay, similar to the text. Okay, don't have some abrupt kind of fonts in the graphs. Okay, because you are doing it in the Excel will give some different types of fonts. No, you have to adjust it. Then flowcharts, photographs, spectra, everything, whether it is going to come in the main paper or supplementary data, it should be properly formatted, right? You should target the audience that you need to identify actually. Where can you publish your paper? Okay, which all journals can take your work? Okay, that you need to study carefully and then choose the right journal, because that improves the chances for publication. Even before writing or submitting your manuscript, identify a journal that matches your research area. Okay, the journal which matches your research area, and then you can look for these parameters also, like scope of the journal. You should look for impact factor, side score, indexing, whether it has indexing in reputable databases such as Web of Science, Scopus, PubMed. Okay, you should look for these things. Then there is an option of open access journals and subscription journals. For open access journals, they will provide your papers for free to the readers. Subscription journals require reader or institutional subscriptions, right? But open access journals may ask you for article processing charge. Okay, you have to pay some article processing charge in case of open access journals. And see if these European journals or American journal, their process APC is quite high because they are charging in pounds and euros and dollars. So it is difficult, right? Then look for the journal, whether it belongs to Q1 category, Q2, Q3, or Q4. Okay, you have to really critically evaluate your work, and then you should decide whether you want to go for Q1 or Q2, Q3, Q4, based on what is your judgment about your work. Okay, you should avoid predatory journals. Okay, because these are the journals that prioritize publication fees over rigorous peer review. They will publish anything you submit it to them without revision. Okay, but such journals are predatory journals. Any good journal with academic research standing on the international level will not accept your paper without revision. Okay, warning signs include unrealistic acceptance time. Today you submit it, within 4 days your paper is published. It is a predatory journal. Poor website quality, fake editorial boards, people somewhere sitting in Nigeria and Ethiopia only appearing the editorial boards is one of the indications. And false indexing claims. Impact factor is 7.2, 5.7. These are unrealistic false indexing claims. Now see, I have tried to categorize popular journals according to research area. As you all are chemistry teachers and researchers, you know about these journals, right? These are the journals published by ACS or RSC, Wiley or Bentham publishers. And these are the popular journals, I would say. So for catalysis also, you have a specific type of journals. Environmental chemistry, you have a specific type of journals. So for each area in chemistry, you should look carefully which journal is related to your research area, and then format your paper in their template and then try to publish it, right? So these are the practical tips for writing better papers. So writing a good research paper is a step-by-step process, right? First of all, you should plan the framework of the paper, right? So then paper, before you write a paper, write the experimental section, okay? And prepare figures before writing. What all material you have, what all data you have. Try to organize that data. Then use simple scientific language to describe what you have done it. You should maintain the logical flow. Always avoid unnecessary jargons. You should revise your paper multiple times. It's not like one, I have written the paper, I have submitted it. No, give it to your colleagues, give it to your co-authors to read, take the critical feedback from them, and then submit the paper. Okay, seek back the feedback from co-authors. Use grammar and plagiarism checking tools, which are available. So plan the paper, right? Step by step. Prepare the first draft and improve it through several rounds of revision. Each draft makes the manuscript clearer and stronger. Once you are satisfied with the quality, then only submit it to the appropriate journal. Okay. After, you submit your manuscript, it goes to editorial screening. So submission process is like prepare the manuscript. Okay. Follow the journal's author guidelines and prepare the manuscript everywhere for all text, figures, tables, references, required declarations. Follow the format. Cover letter should be ready. It should briefly explain the editor that novelty, significance, and suitability of your manuscript for the journal. Then graphical abstract, keep it ready. It's a concise visual summary highlighting the main findings or workflow, right? Then supplementary information, that additional experimental details, spectra, data sets, calculations, videos, everything should be ready as a supplementary information. Use the online submission system, upload everything like manuscript, cover letter, figures, supplementary files through journal's electronic submission portal. Nowadays, that method of sending email is not there. Okay. Then ORCID ID, you should have ORCID ID and you should use ORCID ID for submission. Okay. Anyways, journal will ask you for your ORCID ID. Okay. After you submit the manuscript, as I said, editorial screening will be done. That will decide whether your paper fits in the journal scope and basic requirements. If it passes this stage, then it is sent to reviewers for evaluation. Based on their comments, the editor may ask for major revision or minor revision, or rejection is also possible. Once all the comments are addressed satisfactorily, the paper is accepted and finally published, right? Now, see, one thing is, whenever you get comments on your paper from reviewers, even if it is a rejection, there are some comments on your paper. Don't get disappointed. These comments are for, those comments should be used for making your manuscript better for the submission to some other journal. Okay. These comments are for, they are kind of scientific input, technical input to your work. Okay. Try to resolve those comments, and even if the paper is rejected, while submitting it to other journal, you know that what peer reviewers are thinking about your piece of work. So you can incorporate those particular changes. See, whatever you write, it should be interpreted in more than one. If it is interpreted in more than one way, then it is wrong. Okay, so be precise. You should know your audience, know your subject, and know your purpose. Okay, if there is no reason to put comma in, don't put it. Okay, keep your writing clear, concise, and correct. Otherwise, yes, be prepared. It will come back to you. The paper will be, rejected. But again, as I said, reviewers' comments are always important. Okay. And very importantly, stay away from plagiarism. Using the ideas of someone else without acknowledging the source of information is a serious offense in the scientific community. Credit must be given when using another person's ideas, opinions, theory, or information that are not common knowledge. See, something nucleophilic substitution reaction, you don't have to give reference if you're talking about, general nucleophilic substitution reaction. It is there in the common knowledge domain, right? All textbooks are giving that information. But yes, specific information you are using from some paper, give them the due credit. Okay. And the decision by reviewers depend on the thematic relevance to the journal scope of subjects, significance of your contribution, originality of your work, and coverage of relevant literature. How beautifully you have done your introduction part. That is also important because that is the only way to show that why your work is important. When you tell about others' work, you tell about what is being done, then only they will be able to understand how your work is different and how it is important, right? And also, the strong reputation of author is important. Successful test of the proposed theory is important. If you are applying this, whatever theory you have come up the solution for the problem. If you are creating a model or something, then it becomes more important. Different content from that is usually published in the journals. That is also important, right? So all these things are to be taken care of while trying to publish the paper. And yes, once your paper is published, you feel proud, or like that you are a proud author because you have done this. It's not easy to publish paper in the journal of international repute. If you are doing it, yes, it is commendable. So that is all what I wanted to say. Thank you, and extremely sorry for the disturbances. I couldn't do much about it. Yeah. So I think we are open for discussion. Let me go back to the meeting part. Okay. Just a minute. Okay, so I had joined from another device. I'm back to. Okay. So thank you, and I'm done with whatever I wanted to say, and I would say session is open for the discussion. Please go ahead. Am I audible? Yes, am I audible?
Yes, ma'am. Yes.
Please
May I
respond.
ask a question?
Yeah, thank you. Yeah.
Yeah. Ma'am,
Any
always
questions,
there.
any queries?
Hello, ma'am. Am I audible?
Yes, yes, please go ahead.
Yeah, ma'am. Always there's a question and there's confusion regarding peer-reviewed journal. How can we define a peer-reviewed journal? What should be, what criteria, what quality should be fulfilled by a journal so that it may be a peer review?
Okay. So see, all the journals by respected publication houses, they are peer-reviewed journal. When you submit a paper, of course, you will get some reviews. Sometimes 3 reviewers' comments will be there for your paper. 2 reviewers' comments will be there for your paper. And you have to address all the comments. You have to communicate back to the editor. Editor will send your comments to the reviewers. Then whether they will decide whether whatever solutions you have provided are acceptable or not. So there will be a discussion on that part. When the journal is not peer reviewed, you just send something, they will publish it. But I have seen there are journals, of course, they claim to be peer reviewed, but there is no, no review will be sent to the authors.
Yes, actually that
So
I want
it
to
is,
clear. Every journal writes the peer reviewer.
yeah,
They don't follow the guidelines. Actually, they
no
just
guidelines.
clarify. But still, they are
That is the
writing peer review.
malpractice in the science, actually, and we should be the torch bearers. I don't know whether it is a right platform to talk about it or not, but yes, such things are there. They do exist. Predatory journals.
Okay, ma'am. Thank you very much.
Yeah.
Hello, ma'am.
Yes.
Ma'am, am I audible?
Yes, yes. Please go ahead.
So, ma'am, in your slide, you said that you have to tell a story. So, can you explain by taking some of the example?
Okay. See, let us take an example that I have synthesized diallyl sulfone. Okay. Now my story starts like why cell phones are important, why diallyl cell phones are important, right? Then I would say, okay, what all methods are available in the literature for the synthesis of diallyl cell phone? That also I will talk about it. Okay, all these methods are there available in the literature for the synthesis of diallyl cell phone. Okay, then I will say, but problem is that all these methods are using heavy metal based catalysts. Okay, so that trace impurity remains in the final product. Or I would say all these methods or some of these methods describe that synthesis is done using inert atmosphere. So you have to have a glove box or nitrogen atmosphere for performing the reaction. In these methods, maximum yield you can get is 70%. But diallyl sulfone is very important. You need simple method to make this diallyl sulfone. So what we have done is we have devised a new method. Okay, now I am using some reagent which is commercially available, economically viable. It is not very expensive. It is very simple reagent available, and then I'm performing my reaction at 0 degree. I'm getting 90% yield or quantitative yield. I'm not using any catalyst. Okay, so this is the flow. My story starts ki why it is important, right? And then gradually I'm coming down to, okay, what is there in the literature, but why it is not useful, what is remaining, what is not done, and this is what I have done, and now this is very important. That is what I will try to tell. And not only I will say, okay, using this method we prepared diallyl sulfone, fine, but we prepared dibutynyl sulfone, dipentenyl sulfone, and say many other sulfones using this method. So this method is general method for the synthesis of sulfones. That also I will claim if I have done it. Okay, because anyways I will try to generalize my methodology. If you are doing some synthetic method, you will try to generalize it. Okay, it works with these kind of substrates, so I will say I used benzyl bromide also, not only allyl bromide. I used benzyl bromide also, and I created dibenzyl sulfone. So like that, you create a story of whatever you have done it. So while being there on the bench only, you should think always, how am I going to tell this to the world? And fill in those experimental gaps. If you have not done something, do it then and there. And that is why research guides are important. See, as a student, you won't be able to visualize that, okay, I have to present this to the world. Their research guide is instrumental, because research guide knows that, okay, this needs to be told to the world also. You're going to write a thesis also, you're going to write a paper also. So there should be a story. Even negative results will make a good story. Okay. I always vouch for the negative results because then you have not many things to tell. Okay, we tried to do this, it did not work. This is what the product product was, and then we did the reaction at 0 degrees, and then we got the desired product. So that makes the story interesting.
Thank you, ma'am.
Yeah.
Not at all.
Yes. Any more questions? Yeah. Any more questions? Dr. Manisha,
Hello, Preeti
should we
ma'am.
go ahead? Yeah, hi. Hello.
Dear participants, is there any questions? Would you like to interact with madam? Anyone from you again? So I think, madam, there are no more questions. So thank you so much, madam, for giving your precious time to us and interacting with the participants, sharing your valuable inputs in this very important topic. Thank you so much, ma'am.
Thank you, Dr. Manisha. It was a great opportunity for me that I could interact with my fellow chemistry teachers. Really sorry about these disturbances. It's been raining even now. Okay. So I leave the meeting now. You must be having
For that,
another meeting schedule.
I request one of the participants to propose vote of thanks.
Yes, madam.
Yeah.
Am I audible?
Yes, you are audible, sir. Please.
A very warm welcome to one and all who joined this refresher course. I welcome you all in this refresher course in chemistry organized by Malviya Mission Teacher Training Center, SGBAU Amravati. I am Mr. Nilesh Podode, Assistant Professor from Vinayak Vignan Mahavidyalaya, Nandgaon, Kandeshwar. It's been my absolute privilege to propose vote of thanks for today's session. First of all, I would like to extend my heartfelt thanks to Dr. Preeti Khedkar Madam, Guru Nanak Khalsa College of Art, Science and Commerce College, Mumbai, for delivering this informative session on the topic research paper writing in chemistry from experiment to the publication. Your presentation will definitely help us, ma'am. Thank you very much once again. I am once again, I would like to extend my thanks to course coordinator, Dr. Manisha Kodape, madam, and all members who are involving in this smooth conduction of this refresher course. Thank you one and all. I would like to thank all the participants who have joined this session across the country. Thank you one and all. And with this, I would like to conclude my vote of thanks. Over to you, madam.
Thank you so much, ma'am.
Thank you. So I take your leave. Thank you.
Yes, ma'am. Thank you.
Yes, thank you.
Hello, Dr. Vijay Tangde, sir. Are
Good
you there,
evening.
sir?
Good evening, madam. Good evening.
Good evening, sir. How are you, sir?
Yes, good. Thank you, madam, for inviting.
Thank you so much. It's our pleasure, sir.
Yes.
So shall we start with the session,
Yes,
sir?
yes. I was waiting for finishing this earlier.
Okay, sir. May I now request one of the participants to please introduce our today's resource person for this session?
Yeah, and please provide the privilege of sharing.
Okay, sir.
Yeah.
Ankit,
Yeah, I got it.
I think it has already been given.
Hello, yes, ma'am.
Yes, I got it.
Yes, Dr. Pawan Kumar, sir.
Yes, ma'am. Yes, ma'am.
You are going to introduce?
Ma'am, I am audible.
Yeah, you're audible, sir. Please.
Yes.
Yeah.
Good evening. Yes, sir. Good
Is it
evening to
visible?
you.
Yes,
Yes,
sir.
sir.
It's visible, sir. Your slide.
Yeah. Because the connection is unstable from my end.
Okay.
Yeah.
Yes, sir. Yeah. Good evening to you all. I am Dr. Pawan Kumar, Assistant Professor in Department of Chemistry, Himati Nandan Bahuguna Garhwal University, Srinagar, Garhwal, Uttarakhand. It is my great privilege and honor to welcome Professor Vijay Tangde, sir, to the fourth session of the 8th day program, Refresher Course in Chemistry. This welcome is extended on the behalf of UGC MMTTC organizing team of Sant Gadge Baba Amravati University and from all the participants. I briefly introduced Professor Vijay M. Tangade sir, who is a professor in the postgraduate teaching department of chemistry and also a chairman of the board of study in applied science and humanities at the Rashtriya Sant Tukajoji Maharaj Nagpur University. Sir received a PhD in irreversible thermodynamics, and his research area is irreversible thermodynamics, solution thermodynamics, and hadronics chemistry. Sir has an experience of a 16 year of teaching experience, out of which 6 years for the UG program and 10 years from the PG program, and 1.5 year also in the industrial experience. Sir also has a single point of contact as SWAM NAPTEL Nodal Officer, Mahadhyandeep, Government of Maharashtra. Sir also has received a many grant from the under the Fortune grant received individually from the USA. Sir also received a project under the UGC on the thermodynamic stability theory and its application in real process. Sir also granted a project under the university RTMNU, sir, his university, and low cost absorbent and also biophysical property of drugs. Sir also awarded a project under the Rajiv Gandhi Science and Technology Commission's Government of Maharashtra, a project for the renewable fuel additives. Sir also has a PIZ member for the DST PERS project of the amount of rupees 11.42 crores for the project. And sir also awarded a ANRF fair project 48 lakhs rupees for the DEC derived metal organic framework for the water detoxification. Sir also has an vast experience for the e-developing contents and MOOC for the course coordinator in the SWAYAM ARPIT scheme at the UGC HRDC Nagpur. Sir also awarded developing e-content and a MOOC IIT Madras for the SWAYAM Prabha DTH channel for the specific effective of quantum chemistry, spectroscopy, and photochemistry, and also under the IIT Madras, same platform SWAYAM Prabha DTH channel for the specific elective of physical chemistry under the IIT Madras. Sir also published many journals under the 50 journals, and sir organized 40 conferences, 50 seminar workshop attended, and sir has written 6 books. Sir also organized a workshop and conference about 10. Sir has also for an academic visit in Greece, visited to Kos and Rhodes in Greece. Or sir awarded a PhD student 5 for undergoing the PhD student, 3 PhD undergoing student. Sir also honored many recognition, various honors and recognition, like a member of academic council in his university Nagpur, member of NAC, core committee for the SSR, coordinator for the centralized online PG admission in his university, ex-member of BUS member in Gondwana University. Sir, also experts at the Ministry of the subject expert at the Ministry of the Mines, Government of India for the selection of the research scientists. Sir, also, sir, there's a lot of, yes, sir.
Yes, I'm sorry to interrupt you, but then, yeah, thank you very much for such a elaborative introduction.
But sir,
let us start with the lecture. And I guess these are the points which are to be written on biodata only. But then our time in the lecture is more precious. Thank you very much for introducing me.
The topic on the foundation of quantum chemistry, sir.
Yes.
Now this session is over to you, sir.
Yeah, thank you. Thanks a lot, Pavan sir, for elaborating my brief biodata.
Yes.
So long.
But it's a very interesting topic from the irreversible thermodynamics, sir. Is a physical, most of the important part of physical
some
chemistry.
other time we will discuss the thermodynamics. Right now, currently we will discuss something on the quantum chemistry. And hello friends, good evening to all. I know this must be the last lecture of the day, and probably your faces maybe I mean I can see some of the what the lecture देने की आदत है लेने की नहीं है ना. So please bear with me, and I wish if this can be in a discussion kind of thing. But then yes, definitely I'm not going to teach the classroom quantum chemistry here. although the contents of the lecture will be quantum chemistry related, but then yes, we would like to make the subject interesting, and therefore some of the aspects on why the topic of physical chemistry like quantum chemistry students are afraid of, and where actually we lack. So as a colleagues, we will discuss the topic, and I will try some of my sharings that I discuss in class, and some you may share that any particular point. Some of you may be teaching quantum chemistry or physical chemistry. They also can share the topic. So let us start with it, and let us see how far we can discuss it. So as far as quantum chemistry is concerned, whenever I go to class, we usually start with lot many questions. So to make the topic little bit interesting, we usually start with questions like, can an electron orbit the nucleus like the Earth revolves around the sun? You also try, I mean, whenever you get a chance to ask, these are very general questions, not related basically specifically to quantum chemistry, but then yes, related to current scientific knowledge. So if we ask a student what can be the reason, and even if we think that whether it is a kind of solar system at a tiny level, or you can ask student, why doesn't an electron fall into the nucleus, why diamonds are transparent, why oxygen is paramagnetic in nature although it has two electrons, why two unpaired electrons are there, why do leaves look green, why the sky is blue, why the mercury is liquid. N number of questions I can take out, and thereby I can make students understand using the quantum chemistry basic knowledge. So according to quantum chemistry, if I see, electron actually does not revolve like Earth revolves around sun. So according to quantum chemistry, the answer to the question is no. And thereby we need to understand why quantum chemistry is and what quantum chemistry is. I guess the gathering is comprised of all specializations of chemistry, but then quantum chemistry is such a topic which is common, and this is particularly the reason why I chose this topic. Otherwise, thermodynamics would have been taken very easily, but then many a times it happens like, अरे ये केमिस्ट्री का क्लास है कि थर्मोडायनामिक्स का समझ में नहीं आता है, केमिस्ट्री का क्लास है कि मैथमेटिक्स का, and therefore we have taken this topic particularly. In between, if you stop me and if we can discuss any particular point, I will be more than happy to answer that discussion rather than delivering from only one end. Okay, so please let me know even if you feel like so. So in attempt to answering any of these kind of questions, why this happens? I mean, why there are these questions and why the answers are not that way straight. So if in order to create the interest to students, many a times we have to take student to the history class, or many a times we have to tell a story to the student. So we have to generate or inculcate the interest into the topic. You can also start these kind of interactions, and you can take students back, say 125 years back, and you can ask, imagine that you are in the year 1895, and imagine that almost all scientists, they are believing that we have now completely understood the science. You will be surprising to note one of the statement of Lord Kelvin. He reported, he was the greatest physicist of his time, and he reported that the physics was completely understood now, and there are only few clouds, small clouds remaining to understood. And this was really surprising. And look now, the irony was, these small clouds became the greatest scientific revolution of the history. Later on, when he thought in 1895, he never thought कि आने वाले 50 सालों के अंदर ये पूरा change होने वाला है. So the mystery first time came, and then, oh my God, the speed is too low. Yeah. So the mystery first time came and started with a few questions, those we have seen, and the ultraviolet catastrophe kind of thing when people started doubting. And then people started coming to know that these small clouds are not actually small on entering. So what actually was the origin of the ultraviolet catastrophe, and what was actually that? So scientists initially tried to heat the piece of iron. It initially glowed red. Then after again heating it, glowed to orange, it glowed to yellow, then it became white. And classical physics actually did not predict why the hot object is emitting such kind of infinite energy at ultraviolet wavelength. And then Max Planck came and he made some assumption. He said energy is emitted in tiny packets and he called it as a quanta. It was very surprising. So initially it was his assumption E is equal to h nu. We claim it to be associated with the Einstein. Yes, definitely it is associated with him. But then initially it was an assumption. And you will be surprising, can one assumption change the entire history of science? Yes, that has changed the entire history of science. Then in 1905, Einstein came and he said light had always been considered a wave. And what Einstein said that it comes in the form of particles which we know as photons. And he used the idea of photoelectric effect to understand this concept, and thereby he could get the Nobel Prize and not on the theory of relativity. So Einstein received this Nobel Prize in physics for this work. So people many a times get confused that it is for the relativity, but it is not the fact. And the answers to these questions led to the many of the scientific discoveries like solar cell discovery. Digital cameras are based on this idea, optical sensors are based on this idea, and n number of things we can count which are currently existing on this idea. So this ideas can give interest to the student if we discuss their history in the class instead of discussing the mathematics involved in black body radiation or photoelectric effect, or for the sake of matter, even if we discuss the heat capacities of solid and atomic spectra. These are the things which may create, I mean, mathematical or some technical hurdle. But then if you tell it in the form of scientific storytelling kind of thing, people or students may get interest into it. Once, I mean, this was the initial thing in 1905 or 1910 or 1911 to 13. Then actually the atomic puzzle actually start to evolve by the time. So Ernest Rutherford discovered the atomic nucleus, and his model actually resembled the miniature solar system which earlier in the first slide we had discussed. But then it was actually problematic, and many of the answers was not able to get using these kind of proposals, although it was the initial point. But then such theories could not answer why atoms is not collapsing into the nucleus. And if it is like so, chemistry would not have existed at all, and life would have been impossible. So who is the person then who intervened is Niels Bohr, and he proposed the electron occupy only in certain allowed energy level. And therefore, the whole actually mystery came resolving, and then we could see the resolved picture. In around 1920-24, we started understanding that matter behaves like a wave. And Louis de Broglie actually said that every particle which is moving has a wavelength. Even a cricket ball has a wavelength. And you can actually tell to the student in the classroom, if I throw a chalk at you, whether it will hit you, whether it has a wave. So you can actually tell, yes, it has a wave, but its wavelength is so tiny. I'm sorry. Its wavelength is so tiny that you will never notice it. Everything it has the wavelength. And with this progression, actually the concept of absolute precision came, and people started understanding that nature is such a beauty that it always refuses the absolute precision. And Werner Heisenberg in around 1926 or a conference around that period, he started telling that we cannot have both the exact position and momentum of electron simultaneously, and because by that time, whatever instrumentation we had, it is very difficult to understand. So this was what is the starting of quantum chemistry or quantum mechanics that way. And chemistry at a very later stage, the chemistry had come actually into the picture. So this is what is the origin of quantum mechanics, and whatever limitations what physicists and chemists and mechanics, they were thinking that we understood all the physics in our classical mechanics. This concept came into screw, and with the help of de Broglie, with the help of Schrödinger, the concept started resolving. Heisenberg also played a vital role. This is what is the experiment which you can see on the screen. Probably you may see my cursor, that this is a Young's double slit experiment. And in this double slit experiment, you can imagine this as a water wave. If a light passes through one slit, it gives you one fringe pattern. On the contrary, if you allow the same line to cross through the two slits, it will give you the fringe pattern. And that was what led to the concept of simultaneous wave particle duality of wave particle nature of dual nature of the material. The concept started existing. As I said, the Heisenberg uncertainty principle, as per actual calculations made by Bohr model, we could not calculate the exact position and velocity of electron. And then this Heisenberg showed that there is a fundamental limit to the accuracy of these things, and certain physical measurements are actually impossible. And these limitations, they apply to many combinations of, you can say, dynamic variables like time, energy, velocity, angular momentum. And therefore, it is that way impossible to take the trajectory of electron also. You cannot say that the electron is present at this moment at this particular place. So you can actually fix any one thing at one particular time. And therefore, he proposed delta x into delta p is greater than or equal to h upon 4 pi. And that is actually h cut upon 2. And that is what is the basic minimum quanta that can be measured. And that h upon 2 pi or h cut is known as the minimum Planck's constant energy that is required. Do you know why, how to differentiate between the classical mechanical phenomena and quantum mechanical phenomena? The quantum mechanical phenomena applies to such quantities where there is a significance of Planck's constant. I mean, h upon 2 pi, wherever the h upon 2 pi is significant, my quantum mechanical phenomena justifies. And wherever the quantum mechanical, h upon 2 pi, that is, or Planck's constant is not significant, the phenomena belongs to what you can say as classical phenomena. And so on the things are. What is important? So based on all these observations, all these discussions we started from, say, वो तो काफी पुरानी थी, लेकिन since 1895 we can say everybody was involved into the discussion, and people were searching for the exact model of atom. So later on, during the Solvay conference period, Schrödinger came, and that is known as actually Schrödinger's revolution. The person known as Erwin Schrödinger introduced the wave equation, and with the help of his wave equation, he started a question: where is the electron? The term quantum mechanics itself means how much, and therefore he started asking, where is it, what it is, how is it, how much it is, and what is the probability of finding the electron here? You cannot define. And he proposed some equation, HSI is equal to E psi. We'll come to that point. And initially, then it was thought of that we need to give some fundamental rules for such behavior which we cannot see. Classical mechanics was that way simple by the time we are talking now, because physicists were thinking of understanding everything in mechanical world, and they were having answers to every classical phenomena they thought of. But then at microscopic level, they were failing. At subatomic level, they were failing. They were not able to answer why specific heat of metals did not match with the experimental value. And there the questions were. And therefore, it was very important to postulate or to formulate some rules for the quantum mechanical observations. And here the first postulate came, wherein the significance to, the introduction to the wave function, which is a function of position and time, is given. So people started giving it understanding, and people started understanding what the wave function is. However, still in my class many a times इसके ऊपर बहुत सारा discussion हो जाता है, and it becomes difficult to tell student what the wave function is, because you cannot justify the physical significance of such quantity, and without telling that yes, this exists, but then it can be real, it can be imaginary. I mean, it is really a kind of question wherein you cannot give answers. Yes, the probability is say 50 plus 2i. What is 2i? So either I have to tell that it is a 50% probability, or 70% probability, or 0% or 100% probability. I cannot tell it in terms of imaginary part. So the wave function is such a function wherein there is both the parts are attached, imaginary parts and real part. And therefore, one of the relevant question I have stated on my slide: how do weather department predict tomorrow's rain? So they don't tell you whether where every water molecule will be. Instead, they tell there is a 80% chance of rain. And similarly, the quantum mechanics does not tell exactly where the electron is. It tells about the probability of finding it in a different region. So the wave function is like a probability of the forecast of the electron, and therefore the probability density has got a physical meaning, and not the wave function has got meaning. And therefore the concept of normalization came in. The methodology of normalization and these kind of things, it came in, and you can now tell that we have to normalize the thing. We say you cannot say that in the morning I say there is a 30% probability of raining, and in the evening there is a 80% probability of raining. So the total probability is 110%. So will you tell that in a day there is 110% of raining? No, it's not like that. So you have to normalize now. So you have to take the entire probability, that where it is and where it is not, and combining the entire region for such probability, you normalize the function which belongs to the same finding. So the electron may be anywhere in the space, but the probability of finding it somewhere in the entire universe must be 100%. And therefore, these electrons stand somewhere, that the integral psi into psi star d tau is equal to 1, or psi square d tau is equal to 1, if both of the wave functions are real. You know for sure where the electron is. And that is what is the condition. Apart from this, there is one more aspect in this particular equation. If you see that the quantity 1 upon n is introduced, which is the normalization factor. So we have to also decide now by how much fraction you have to normalize the probability. So that multiplying normalization factor is equally important in quantum mechanics to quantify my probabilistic nature, and that's why it is given. A similar concept is about the orthogonal functions. When we have talked about the 100% probability, we should always talk about the null probability, or what I can say, forbidden probability, because it is not always clear to compare two different hands which are working separately. I cannot compare their efficiency and their probability. So if the two functions, they are normalized as well as orthogonal, they are said to be orthonormal. But then when you say that these are two distinct functions belonging to different surfaces, both of them, they are normal. There, if you take the entire probability, it becomes 0. So integral minus infinity to plus infinity, d tau is becomes 0. So we have also tried to compare. I mean, we should tell the student on the same slide or on the same board what the normalization means and what the orthogonality means. I mean, there should be some common factor to understand the orthogonality even. So these are a few of the aspects which we can tell to the students to understand the chemistry even based on it. We can also make students understand why atoms form chemical bond in this way, why molecules have specific shapes, why oxygen is paramagnetic, why carbon forms million compound, why some substances are conductor while others are insulator. And there are n number of things we can make students understand based on such concepts. And in this way, the chemistry becomes predictable, and we can also tell them why these are the fundamental physical laws, because there are no bypass to this theory. We can also make students to understand the existing technologies which are firmly based on the quantum mechanical outputs. Yeah. Am I audible? Because my connection is very frequently going unstable.
Yes,
Am
sir.
I audible?
Yes, sir, audible.
Yes, sir. Yes.
Thank you.
audible.
Yeah, thank you, sir. So there are certain basic things. If I make students know that lasers are the techniques which are directly dependent on the quantum mechanical phenomena. LEDs which we are looking for, MRI scanners, solar cells, semiconductors. For the sake of matter, अभी नए जो टीवी आए हैं quantum dots in television displays, or computationally designing a drug without actually going into the lab, we can predict their behavior. Modern quantum chemistry softwares, Gaussian we can use, we can use many other latest softwares which are actually make a sense of understanding. And I mean, in a classical way, it will be difficult that way to understand or to tell the student why this is happening. But then, with the help of quantum chemistry, you can actually tell the student why the color is like that. Why you are looking at every color you are looking at is because of the quantum chemical phenomena. Every chemical bond we study, every reaction we investigate, or every reaction we carry out in laboratory, every molecule we design, and ultimately whatever we do, it obeys the quantum mechanical law. The mobile in your hand, the frequency the mobile receives. The best example of telling the quantum mechanical phenomena is the explaining the mobile microwave waves into the room. Right now, everybody sitting all together, if we are sitting in a classroom of say 100 students, each of the student will have a mobile, and the microwave frequency for each of the mobile is different. They are receiving a different frequency. There are, at the same time, in the room, there are IR radiation, there are some radio waves, there are some visible waves, there are some X-rays and whatnot. If as a human being and our human eye is able to see all the waves, probably we could have seen nothing. There would have been a blank screen in front of our eyes. This is surprising. So beautifully nature has gifted us such eyes which filters all wavelength. We cannot see UV, we cannot see IR, we cannot see X-ray, we cannot see gamma, we cannot see radio waves, we cannot see microwaves. The only thing we can see is visible wavelength. 350, 400 to 700 we can see. And beautiful nature we can see, billion number of color combinations we can recognize, and we can separate even. So that's what is a beauty of quantum chemistry that we see. Then comes little difficult part to tell student. Now this is a part where I personally feel that yes, this is a thing which I am afraid of telling student. Yes, although after say telling all the interesting stories that why the gold is yellow, why the leaf is green, why the mercury is the only common metal that is liquid at room temperature, why my diamond is only transparent, how the band forms. After telling everything, when I come to this mathematics, again, the interest of student goes off. So what I do, I usually tell to student, look at this and don't memorize, try to memorize it. If you understand it, it's good. If you don't understand it, forget about it. We will not do mathematics for the sake of mathematics. We'll only understand it as a tool, like an end user. There are n number of tools which really doesn't require nowadays to memorize and to see how the algebra of quantum mechanical operator works. There is absolutely no need. The only thing is we need to understand how the phenomena is taking place. We need to know the answers to questions like why oxygen have two unpaired electrons, why Levy's concept is not applicable, why it is not diamagnetic. So chemistry exists and the quantum mechanics exist, and we need to give them answer. We need to justify these things based on the student's perspective. These are some operators which we usually tell into the class. For examination point of view, it is okay, but then to make them understand, it becomes little difficult to tell them. But then yes, as a part of examination and as a part of understanding the operation of algebra, we need to tell them. I will not spend my time on this particular part, how the quantum chemical operators are derived. The mathematical derivation is given because it is a wave function. How wave is designed, amplitude has to be given, and some exponential function has to be there, and plus minus real and imaginary part has to be taken care of, and therefore the equation psi is equal to a into exponential of plus minus 2 pi I x upon lambda, whatever lambda is, whatever x is. I will explain to them, and this is how the equation momentum, x direction, how they are derived, everything I can tell them. It's okay. Angular momentum, what the angular momentum is, why angular momentum is important. I usually does not get into the mathematics, which is I am showing it right now currently on the screen. So what do? I tell them an example of riding of cycle. If I ride on a cycle and if I go by a straight way, I'm moving a classical motion. Now at the moment, my cycle is on the curvature road. So my mechanics changes. So how when on the same road or on a plain road, the center of gravity remains inside the body of my cycle. The moment I twist, I turn on the curve, the center of gravity shifts from my cycle body to the road, and therefore the centrifugal force appears into the calculation. And angular moments, so momentum P is equal to mass into velocity changes to angular momentum L is equal to I into omega, where I is your moment of inertia and your omega is angular velocity. Whole equation changes, like P is equal to M into V changes to L is equal to I into omega. And then the entire circular motion, how it takes place, that has to be done. Now, why to consider the circular motion? Because our fundamental assumption is that the electron cloud is circular in motion around the nucleus. And therefore, it is not wise to consider the linear motion. It is always wiser to get the circular or angular motion. And therefore, I need to tell them why angular momentum has been taken into place. Then come the very interesting aspect of the quantum mechanics. Usually I say the most beautiful equation of quantum mechanics. And I call it as, see, this is of the form. A psi is equal to A psi. A very simple equation. I usually, whenever I see, I do not say that every one of you should listen to this lecture very carefully, but then at least those who teaches quantum chemistry and those who are physical chemists or even organic chemist, even this equation is very fundamental. And there are certain things, even every teacher has got their own way of telling the stories and discussing the contents into the class. Now, A psi is equal to A psi. A is the operator psi. When operates on psi, it gives you some value A and psi. Now, it is so boring. It is so boring to tell student why this equation exists at all and what is the use of this. So I always relate this equation to PV is equal to nRT. Now I ask them which equation is simpler. As a chemistry student will say PV is equal to nRT is the easier equation than A psi is equal to A psi. I hope many of you will agree with me. PV is equal to nRT. Students will say it is easier. It is exactly like that the advertisement of Fair and Lovely. बार बार देखने के बाद में वो बच्चा भी समझ जाता है कि PV is equal to nRT केमिस्ट्री का इक्वेशन है. And A psi is equal to A psi or H psi is equal to E psi. These equations are quantum mechanical equation and these are for mathematics purpose ये उनके दिमाग में भर गया है. Just to give an answer, now if you look at it, PV is equal to nRT and A psi is equal to A psi. If you look at it, in which equation variables are greater? Obviously, in PV is equal to nRT, there are three variables: pressure, volume, temperature. You need to know gas constant. You need to know the value of n, and therefore it is assumed that PV is equal to nRT. Pressure measure कर सकते हैं, volume measure कर सकते हैं, temperature measure कर सकते हैं, and therefore it is easier. But then to measure the pressure, you need a barometer, or you need some tool to measure the pressure. To measure the volume, you need some instrument. To measure the temperature, you need some instrument. And you do not know what happens to the body when you measure or you carry out the operation. That means actually what is happening in dealing with PV is equal to nRT kind of classical equation, I always need one operator to measure each of the quantity. Whereas in quantum mechanics, this is a tool which tells you how to measure the quantity itself. So say for example, a cowman, if it operates on a cow, or milkman operates on a cow, it will give you milk and cow back. You can make a funny example into the classroom. If psi is your cow and this operator is milkman, and this milkman is operating on cow, this small a is actually your milk and you are getting your cow back. So these are the equations in quantum chemistry. The third postulate tells us that there are certain equations when the operator operates on any of such function, it gives you back the function and some value which that measured. Say for example, if you go to a doctor and you measure your BP. So BP meter, doctor usually attach that BP meter to you and then BP is measured. BP measure करने के बाद में body का क्या होता है? आदमी मर थोड़ी जाता है. So your body is back and measure is displayed. So same thing is temperature. A thermometer is attached to you. You measure the temperature. Your body is back and temperature is measured. These are some of the examples which actually can represent these kind of equations. These are simple equations. Why these equations become difficult? Because at later stages, when at microscopic level you go, each particle has got its own way of defining this psi. And when you define it, when you operate it, it becomes mathematically difficult. And that is what we need to tell them, that how to deal with such mathematics. And that's what is a problem. So whenever this kind of thing happens, whenever an operator operates on some particular function and you get the function back with some value, such functions, they are called as eigenfunction. And the constant of multiple like small a, they are eigenvalue. And the operator is known as eigenoperator. And this equation as a whole is known as eigenequation. In German, this word eigen means a proper value or an approximate value. That means since the value of psi is not known, this actually gives you the approximate value. And therefore, the name itself tells you that it is the eigenfunction. Is it? And thereby we can make the simple thing very easy. Why it is called as eigenfunction? Because it is a proper function or approximate function. Why it is called as eigenvalue? It is not an exact value. It is an approximate value, or you can say a proper value which we assume or which we calculate based on certain assumption or certain operations. This equation is actually known as eigenequations, and there are various ways of finding out this. So these are again the mathematical example which we actually do not like. I do not personally like to display it in a classroom, but then yes, these are the part of academics. Like ddx of e to the power 5x. So 5 into e to the power 5x, when I operate this ddx and operate on this e to the power 5x, I get e to the power 5x back. So such a operator is actually eigen operator. Such a function is eigen function. And this 5 is eigenvalue, and the entire equation is known as eigen equation. Whereas if you see the second value ddx of sin x, it is not. These are few of the basic example which you can explain to the student based on these concepts. Then there are certain concepts in quantum mechanics, Hermitian operator, many a times we need to justify student why these operators are and why we have to consider the terminology like Hermitian operator. And therefore we try to define, like every time, like I cannot say, like whenever I go to a weighing machine and if I measure my weight and if it is said like your weight is 70 kg, if your weight displays that your weight is 70 plus 5 I kg, I is imaginary number, you will be confusing. So your weight is not correct in that sense. You need to tell the real value. So make it real. We need to operate with certain kind of functions. So Hermitian operator, they actually gives you the a normalization kind of value. So the Hermitian operator basically gives you such a tool to operate on, and that's what is a condition of students that why we do normalization. The normalization gives every quantum state a valid probability that yes, this is a particular probability of the particular state. And orthogonality states, orthogonality, what does it give? It gives you a unique identity that this is a particular identity to this particular thing or this particular function. This is what is a difference. Many a time student ask me why I have added this letter at later stages to my presentation is, sometimes student ask, sir, सब कुछ समझने के बाद में, sir, why do we do normalization and why do we do orthogonal, consider orthogonality? So two different things are these. To finalize the probability, you have to normalize. There will be some multiplying factor to it. And that normalization factor, unless you have that normalization factor, you cannot finalize the quantity or you cannot quantify the probability. Whereas you will not be able to give the unique identity to the quantity unless you apply orthogonality. This is what is a basic difference to these two things. These are very basic things which we need to tell students basically to give the physical significance of the mathematical terms, because in many of the textbooks only mathematical terminologies are discussed. Many things are there which cannot be explained. In many textbooks, in a funny way, there are several questions asked. Like you also can ask to your students, can a cat be alive and dead simultaneously? And students may remind of the very famous Schrodinger's experiment, that in a box there is a cat, and that Schrodinger cats how at the same time it can be alive and it can be dead. So you can have n number of questions based on these ideas. How does the sun shines? So do we require a fusion? And why the classical mechanics cannot give answer to the fusion? And why a fusion kind of phenomena cannot be explained on the basis of classical mechanics? Because, I mean, we need to tell them that it is a quantum tunneling phenomena. And therefore, there are many things which we cannot tell students, like DNA mutation. You cannot explain on the basis of classical mechanics. It requires classical mechanics which influences the biology. Is it? So there are n number of examples. Now AI has come. AI has helped the students to understand many of the complex phenomena क्या होता है chemistry में because biology. So you need to tell them how protein structures are, like how drug molecules are being designed, how new pharmaceutical drugs are designed, and where the quantum chemistry is playing role in computational chemistry. How do we use these softwares like James, Then there is one more software. I forget its name. Orca, very indigenous. I mean, a lot of Indian people are working on it, and they are making these predictions. You can show the shape of electron cloud in a picture. Earlier it was not possible, but then now with of orbital, we can show beautiful pictures of molecular orbital diagram. Why energy is lower, why energy anti-bonding case. There are n number of things we can explain based on it. There are a few things which are again, as I said, mathematical, but yes, then these mathematical things, they are very important to state actually, or to tell the students in order to understand the concepts. These are two very important properties of Hermitian operator. That one is the eigenvalues corresponding to eigenfunctions and Hermitian operators are always real. So how the value is real? I mean, as I said, A operator operates on a wave function and gives you some small a value. So this value which we observe is real. As I said, मैं वजन कांटे के ऊपर खड़ा हुआ और मेरा वजन अगर 70 + 5i दिखाया तो it is confusing. सो मेरा वजन जो है हमेशा रियल है, तो मेरा बीपी हमेशा रियल वैल्यू में ही होना चाहिए. अगर मेरे बॉडी के अंदर जितना ब्लड है उसको मेजर किया जाए तो वो लीटर में मेरे को एग्जैक्ट वैल्यू मिलनी चाहिए. All these things are real examples. So the value or HSI is equal to ESI. Whatever energy I measure of the system should be real. If it is imaginary, there is no point in discussing the quantum chemistry. And therefore, this particular property of Hermitian operator is very important, that the eigenfunctions, eigenvalues corresponding to different eigenfunctions are real. You know, eigenfunctions can be real or can be imaginary, but then eigenvalues has to be real. Energy has to be real. Blood pressure has to be real. Volume has to be real. Temperature has to be real. Weight has to be real. Yes. And therefore, unless these are the real quantities, you cannot add them up to have something which is concrete and real. And the second postulate is eigenfunction corresponding to the different eigenvalues are orthogonal to each other. Again, I say that to define the identity of each my orthogonality. Otherwise, I will not be able to tell whether it is my left hand, whether it is my right hand, whether it is my hand, whether it is your hand. And therefore, the application of orthogonality is that way important. Anyway, likewise, the fourth postulate of quantum mechanics is there. I will not go into the mathematics, as I know you all are teacher and those who are teaching, they are aware of these things. These are very basic things. How the momentum deviates. Particle in one-dimensional box is that way a very interesting thing in the quantum mechanical and the history of quantum mechanics, wherein we could generate the principal quantum number origin, and we could tell how the particle in one-dimensional is behaving. The cathode tube, to put two plates of capacitors, and in between two tubes, when it is electronically connected, the electron moves in between two plates. It won't deviate. So the motion is exactly like the one particle in a one-dimensional box. It moves in one direction only. That's what is the exact example of particle in one-dimensional box. When I solve this particle in one-dimensional box, you can see I will not go into the mathematics of it, applying boundary conditions we get. But then yes, definitely, if you look at the slide, my energy comes out to be k square h square upon 8 phi square m, and the n, which is equal to n square upon h square upon 8 n a square. Now this is very interesting and very useful thing which has come. Now this is a kind of law which we get. It gives you the origin of this n, and this n is considered to be the principal quantum number, and this is the origin where you will remember. I had given you the example of what I say, why the electron jumps from one level to other level, because it has a distinct level of its periphery, and therefore it can jump from one level to other level. It does not have a continuous band. And this was what Neil Bohr also proposed once upon a time. that the electron occupy only certain allowed energy level. And actually these electrons can jump between these levels without existing in between them. मतलब एक तो वो n is equal to 1 पे है या n is equal to 2 पे है या n is equal to 2 पे है या n is equal to 3 पे है. ये 2 से 3 के बीच में नहीं है या 2 से 1 के बीच में नहीं है. वो स्टेयरकेस पे नहीं बैठता. वो एक तो फर्स्ट फ्लोर पे रहेगा या सेकंड फ्लोर पे रहेगा, ग्राउंड फ्लोर पे रहेगा या फर्स्ट फ्लोर पे रहेगा. That is what Neil Bohr has proposed, and this equation gives the concrete justification that E is not a continuous function, and therefore you can never differentiate this function in quantum chemistry. Please mind it, because this way mathematically it will not have any kind of significance. And this is a very concrete output in quantum chemistry we get. Once again, we normalize this function, as I said, and we find out the value of normalization factor A, which comes out to be square root of 2 upon A. And because of this normalization factor, we can actually predict the behavior. So why 0 point energy? Because every particle, even if at the absolute zero of temperature, it will always be having a minimum of this much of energy, that is h square upon 8 ma square. And as I said, you see this h, this is the Planck's constant. Unless for a particular system this h is significant, my phenomena is quantum. The moment my h becomes insignificant, the phenomena becomes classical. So my energy, unless it is dependent on h, that is it is defined by h square upon 8 ma square, and the phenomena is quantum mechanical, and it actually gives you E is equal to h square, that is n is equal to 1. If I substitute, it gives you the ground state energy or 0 point energy, which tells you this much minimum amount of energy every particle has got. It is not lower than that. That means there is no case of zero energy. Zero energy doesn't exist. Yes, 0 point energy can exist, which signifies some amount of energy. Zero energy नाम की चीज ही नहीं है. Whenever many a times we quote in a quote from Bible that yes, if initially it is said that he, matlab God, he created light, then he created space, then he created light, and then he created the matter. So whatever it has got energy. So we have to see what is that minimum amount of energy every particle has got in the universe. And probably this is the thing we do not guarantee, because this is science. You cannot guarantee anything, because with the advent of science, you may contradict anything. There are certain things which may prove that this is a contradiction, but then yes, right now, this has solved lot many mysteries for us. Therefore, we consider this as a 0 point energy. For n is equal to 2, next step higher, n is equal to 3, next step higher, and so on, it will give you. But then this E is equal to h square upon 8 m square is, for that sake of matter, is a 0 point energy. And my wave function is psi is equal to this normalization factor of square root of 2 upon a sine of pi x upon a. This is for one-dimensional particle. Keep in mind. And that's what is a great thing. I can actually calculate for n is equal to 1, n is equal to 2, n is equal to 3. I can calculate the values, and I can actually plot them in mathematics. So when you show students that how beautifully the shapes, symmetry shapes are formed with these mathematical wave functions, they get some kind of interest. So what do I do? Before starting my particle in one-dimensional box, I show them that yes, look at these beautiful animations. And now how do I get them? Then I start with this. So you would like to learn how do I get them? Let us start. So then they will get some kind of, so this is not mathematics for the sake of mathematics. This is just, there are some things which we can make sense of. These are the textbook diagram you can relate to the students, and the same diagram you can animate to the student so that they can have this. Non-quantization also you can tell. Then come the concept of particle in three-dimensional box. I'm going little faster. I'm sure I'm not here to teach anything to you, and therefore I'm going very fast to give you the glimpse and the points which we need to discuss or with the students that only I am discussing, or the points which I do little bit in a my way, that those I am discussing here. These are the animated figures. I also forgot to tell you, you can see on each slide there is a top header. So I'm sorry, because these are the lectures which I prepared for IIT Madras Swayam Prabha DTH channel, and the same presentation I carry it over. So the contents are the content belongs to the same DTH Swayam Prabha channel lectures, wherein these things are given. These lectures are also available on YouTube and DTS Swayamprabha channel. These are available, and these animations I have done it on my own, like the particle moving in a three-dimensional box. This is all done in PowerPoint. Then in particle in three-dimensional box is exactly the replication of particle in a one-dimensional box. The only thing is we have clubbed the three dimensions along X, along Y, and along Z, and we have clubbed it. Nothing else. And if you read it, you will get the entire idea. You can see we have clubbed the normalization factor and all the dimensions of the box. You get the total energy in three-dimensional box. The beautiful thing which comes out through the three-dimensional particle in three-dimensional box is it gives you the opportunity to define the degeneracy factor. And that too is degeneracy from the point of view of symmetrical aspects, like for a cubic, for tetragonal, for monoclinic, how this degeneracy behaves, that also you can tell them into the same quantum chemistry class. That is the beauty of it. So minimum amount of energy that any particular particle in a three-dimensional box can have is this. That means if n is 1 in all the three directions, so it will be 1, 1, 1. So minimum amount of energy for any particle in a three-dimensional box will always be 3h square upon 8m square. Likewise, you can go on. E111 will have 3h square upon 8m square. Like nx, I'm sorry, this nx should be subscript. Then wave function is like this. Then along any one of the direction, my principal quantum number can be 2, and rest of the two directions it is 1. So like E211, or it is E121, or it is E112. My energy of the particle becomes 6h square upon 8m square, little higher. Now student becomes confused here. What exactly do you mean with the degeneracy? Then I really need to plot this wave function in a special way. And you have to tell them what is meaning of 211, what is the meaning of 121, and what is the meaning of 112. So for this, what I do, I need to explain them the concepts of degeneracy, and I usually explain them in this fashion. You can see this animation which I tried to put here. When I say 111, there is no degeneracy. It is all non-degenerate state, one state. When I say 211, it has got three different states. I'll come to the point what I said. When I say 221, again three degenerate state. When I say 222, it is again a non-degenerate state. There is an in-between state, that is 311 and 131 or 113. And how can I represent these states? Look at these figures. See, 211. If you look from the x direction, you see the two balls, whereas along the x direction and along the z direction, if you see the lines, if you see the blue lines along x direction, you see two lines. So degeneracy becomes 2. Whereas along z direction, it is 1. And look at the red line along y direction, it is 1. So green line represents z direction, red line represents y direction, and blue line represents x direction. The moment I say it is 1, 2, 2, 1, 2, 1, so along blue axis, that is x direction, it is only 1. You can see only one ball. Whereas along y, see the red lines, you can see the two balls. So my degeneracy is 2. Then along z, green line, again it is 1. You can also give the example of an apartment. In a particular apartment, there are suppose 3 flats on each floor. And if suppose there is only one flat at any one of the floor. So say first floor has got only one flat. So you will say there is no degeneracy, there is a non-degenerate state of one flat. Entire floor is for the one flat. One family resides over there. Whereas if you go upstairs, there are 3 flats. So the entire floor has got same energy. Floor is same, but the degeneracy is different because the energy is different. Because each flat has got different family, and therefore energy is different. And therefore, you can say, I mean, not energy is different, energy is same, but then yes, their identity is different. Wave function is different because the family residing inside each flat is different. This is how you can relate the concept, or I usually relate this concept. Now, these are the figures which, if you put these equations and wave functions in Mathematica, or even if you say ChatGPT, it will give you these kind of figures. Then come the example of harmonic oscillator. why the periodic motions has to be explained. We have n number of things that we can we can ask the student to understand. Actually, it is very important to tell students why